How you guys doing? So this is Neil, and this video has been a long time. I mean, some of you guys have been waiting for this video for literally years, and I do apologize about that. I've just been so busy with my business and everything. I have a hard time even putting free art not art courses, but free art lessons here on the channel, and I do plan on getting back to that. I'm starting to free up more time now, so yeah, be prepared for that too. But anyway, so this is all about my worldview, my philosophy, how the world works, which I'm actually going to be turning this part of it, what reality is, how reality works, why is there something rather than nothing, how could it be within a physical world, within an actual naturalistic physics point of view of the universe, that life can actually exist after death. And I'm going to go through a lot of really cool stuff in this video that explains things like how does the delayed choice quantum erasure actually work, can a particle actually appear many places at once, or is that an illusion? Is the Copenhagen interpretation correct when it comes to the double slit experiment and the delayed choice quantum eraser or the quantum mirage, things like that. So this is really, really cool, but this only deals with one small aspect of my philosophy, which I plan to be working with a physicist soon to turn it into, or attempt to turn it into, an actual physical model of the universe with physics and mathematics fully backing it up, and then hopefully experiments to prove that and turn it into an actual theory of the universe and why it is what it is. You'll notice that it's very similar to like the holographic principle or delayed choice or digital physics, different models within digital physics, but it does differ in many ways, and it's really cool. So for those of you that have been waiting for this, then right now is the time you're about to hear it. I do want to give a couple just disclaimers out there. I derived this based on a lot of different things, but mostly experience and obviously evidence. Evidence is super important, looking at the stuff. And what I think this is important because I think it's so convenient that most everyone believes in something about the majority of how the world works, whether they think it's a God controlling it all and you go to heaven or whatever it is you believe in. Isn't it convenient that most people believe in something that makes them happy? They're satisfied with how the world works, with how reality works. I'm not. I don't like the way reality works. I don't like the rules, but I can't change that. I can't make believe. I can't live in a make believe world. I can't just pretend like reality is something I want it to be. I have to go by the evidence and my experiences I have. And anyway, so I just want to make that disclaimer that I actually don't like the way reality works, but it works the way it works regardless whether we like it or not. And you got to ask yourself that question. Do you like the way reality works? I'm not talking about the little stuff like people dying, people starving, that happens. But you probably have some sort of worldview that explains all that, and that makes you happy. Do you like the fact that death exists? You probably have an explanation that explains all that. Do you want an actual, scientific reason how life could exist after death? That does exist within my philosophical view, and other things are definitely possible. Within the view that actually will become a actual scientific model. It's just a matter of working out all the math, all that kind of stuff, but all the concepts are there for it to turn into a fully workable system. Then it's just a matter of finding, and there's enough evidence already out there showing a lot of it. That's what I came up with in the first place. That is physical evidence by physicists. Okay, so that being said, let's get started. And if you guys want, if you haven't already done so, and watched my videos about the delayed choice quantum eraser, which will actually blow your mind. If you understand it, it's going to blow your fucking mind, period. So that's the links in the description below. So just read the description, click on it to maximize it, and you'll see that link there. If you're not familiar with the double slit experiment, sorry, brain fart there. If you're not familiar with the double slit experiment, I kind of explain it within that delayed choice quantum eraser, blow your mind stuff. But you can also watch other videos on it that kind of explain it in different ways to get an idea. That itself is mind blowing. And the idea that particles can seem to appear at many places at once, or all infinite places supposedly at once. It's going to go with is the world that we live in what we think it is? Does solidness actually exist? Things like that. And once you understand how I view the universe and what the universe actually is, what reality actually is, how it actually works, then I'll start to go into how from that you can see how, oh yeah, it's totally possible that life could exist after death. It doesn't mean that immortality can exist. And that's one thing a lot of people really want to be real, is that for us to be immortal. But it's possible that we could actually live on forever in a physical way, in a natural way. So with no further ado, let's get started with Namicism. So Namicism is what I call my philosophy. I'll talk about that later if people care to know why I call it that. I have a piece of paper in the background because some of the stuff I'm going to have to draw to explain a little bit to make it more clear. Most likely I have to draw some of it. Right, so the first thing is why is there something rather than nothing? That's a huge question to ask, right? And people ask all the time. Why do I exist is another huge question. Why do we exist? What's our purpose in life? And some of those questions you might never find a satisfactory answer for, or you might just make one up, and that will satisfy you. So why is there something rather than nothing? Well, think about this. True nothingness is not turning out the black and seeing blackness. True nothingness is not an empty vacuum in space. That's still something. That's an empty vacuum. It still has potentiality. It still can have chaos. It can still have, somethingness, right? We're talking about true nothingness. True nothingness is void of everything. It's void of potential. It's void of change. It's void of darkness. It's void of vacuum. It is almost incomprehensible because it's truly nothing. Whatever you try to think of in your mind as true nothingness, you're most likely thinking of somethingness, like darkness or something, or some void, some black hole. That's a somethingness though. That's not nothingness. True nothingness is void of everything. So here's why there must exist somethingness, and this is why there's something rather than nothing, because if there was a nothingness, it has no potentiality to change. It cannot change because it has no potentiality. It has no randomness, has no chaos. It's void of all that. True nothingness is void of everything. Therefore, nothingness, if it existed, could never become a somethingness. So somethingness would not exist. So that's why there is a somethingness and not a nothingness. Because there's a somethingness, that's why. The answer is quite basic when you hear it at first, but it's deep when you think about it. And that I gave you the long explanation of it, but that is the argumentation for why there must be a somethingness now that's eternal, and that's why there must be something eternal. So that's the argumentation that began to lead me to a different view of the world. Somethingness must be eternal, right? We can't just have stuff popping from nothingness because it's impossible for the reasons I just stated. But what is that somethingness? That's where this whole entire video is going to go into. What is that somethingness? What is reality exactly? And a lot of people don't take the time to try to develop this kind of stuff. They just read some book and believe what that person says. But there's enough evidence out there to support this concept. But we know now already, based on the argument, that we have to at least have somethingness that's eternal. It has to have always been there. So the simple answer is, why does something exist rather than nothing? It's because that's the only way it can be. Meaning, that's the only way somethingness can be, is that it is. Because if it wasn't, then we'd have absolutely nothingness. So does that answer the question really though? Why is there something rather than nothing? One can still say, yeah, okay, I understand the logic behind that. If there was truly nothingness, then there would always have been true nothingness. So why isn't that the way it is? Because true nothingness is incomprehensible. Right? And one can still say, okay, but maybe reality would be incomprehensible, but it's not. Instead, there's a somethingness. And we know there's a somethingness because you can think. And the fact that you can think, the fact that you can doubt that you're thinking, only proves that you're thinking, because doubt is thought. So we know that there's somethingness. And based on argumentation that nothingness, true nothingness, can never become somethingness, we know for sure that there is an eternal somethingness. What is that eternal somethingness? Some will say it's God, some will say it's this, some will say it's that. I'm going to tell you what I have come to the conclusion it is, based on hard science, based on physics. I love physics, as a lot of you guys know, and based on my experiences with the world, with reality, how it works, so forth. Again, I want to tell you, I do not like how reality works. If I can invent some new way for it to be, it would be totally different. Okay, now, so what is the somethingness? The somethingness is eternal, infinite information, meaning information in the sense of actions, of stuff happening, right? Information in the sense of maybe just like sort of binary code, but it's not really binary in my view, but it's packets, little packets, fundamental packets of action that does stuff and interacts with each other. And I call them purons. And these purons interact with each other eternally and always have acted. Now first I got to explain it from a linear point of view, as if the A theory of time are correct. Now I'm going to use some phrases that you might not be familiar with, like A theory versus B theory of time. Others might be very familiar with it. But basically, A theory of time is a linear time. You have a starting point, and it goes on and goes on, and maybe there's any point, maybe there's not. In B theory of time, the entire thing that could exist and does exist has always existed. So everything that could exist has always existed in B theory of time. The problem with B theory of time is explaining how does consciousness work, since we move in this linear type of fashion. Quickly, as a side note, concerning time, Einstein said, the past, the present, and the future are illusions, no matter how persistent. Now, why did he say that? Because he knew it based on what his calculations had told him, what his theory of relativity, both general and special relativity, has showed him. And you'll hear people like Dan Green and stuff explain this in different ways. There's a really cool video that he put out and it's on YouTube, where he shows like slices of bread, and each slice of a bread is a part of time, and he shows like this bicycle, one moving away from one moving toward you, showing how their slice in time based upon Einstein's equations, which have been proven to be true. Well, maybe we can't say proven, but they definitely have been shown to be true over and over again throughout many, many different experiments, that time is truly relative. So depending on how fast you're moving in space and where you are located from each other in space and time, your past can be totally different than somebody else's past. I'm going to explain how that can truly be, and I'm also explaining the twin paradox in a way that's probably never been really explained to you before, or never even been, I'm sure it's been thought of before, but I never heard it before. And it derives from my idea of how reality works. Okay, so now that we kind of have an idea of what that somethingness is, well, how does it work? And this is where I think a drawing might help explain it a little bit better. So again, like I said, first I need to explain it in a linear way, as if it progresses from some sort of linear fashion, from point A to point B, and it grew out to be what it is now. But truly, it's always been, and I'll explain how that is later, and then how consciousness works, and how it comes about and stuff in my worldview. So I'm going to draw a line. This line's going to represent Planck time. So this line right here represents Planck time. It's actually Planck space and Planck time. Now hopefully you can see that line I'm trying to draw with big fat Sharpies so that the lines are visible. Unfortunately, in this mode I can't actually zoom in on this, but what I could do is I could move the camera closer to the page so you guys can see here. So I'm going to be off page here just for a second while I explain this and draw it. Let's go ahead and make sure it's focusing on the page. Focus on the page. There. Okay, it doesn't want to focus on the page. Focus on my hand maybe first. Okay, so this represents Planck time and Planck space. Now what that means is math breaks down at this point. All of physics and all of math and everything that we understand about the universe breaks down at this point. It becomes nonsensical, nothing makes sense, we don't know. Like as far as we know, that's the end of everything. And in Planck time, in Planck space, you have, if you imagine it, there are discrete pieces, discrete movements. It's not continuous. Meaning that within this, these are lines I drew, I don't know if you can see that, but I'll draw them taller. This is how things would move in Planck time and Planck space, meaning that they don't move continuously, but they're changing of states. Now what's important, this is all the world that we live in and understand, right? When we get up here, this is the universe that we live in and understand. Let's say it has a Big Bang, that is our universe, has a beginning point, and our universe begins to expand out, and it's expanding out. And let's say right now we're kind of like in this stage of it right now, somewhere in that stage right there. Meaning that it started as a small point, and then it expanded out and got bigger and bigger and bigger. And this is what we understand right now. And this is where we are right now. We can call this our present right here. This is our present. Now there's different ideas, different theories of what will happen to the universe when it's done. Maybe it'll collapse back down into a singularity. Maybe it'll expand on forever and keep on stretching out and out. Maybe it'll rip apart. But let's suppose just for a moment that I'm correct, and it's going to collapse on itself again. Now this is popular in it's called the New Cyclic Model by Neil Torok, I believe. And in the New Cyclic Model, there used to be an old cyclic model that doesn't work, mathematically been shown to be wrong. The New Cyclic Model works and could actually be true. And within this, there's one universe that has had an infinite amount of expansions and collapses. And because it's a cycle that happens over and over again, it doesn't have the idea of infinite regression. Because you can't say a circle has infinite regression. You can go around and around in a circle and that's not infinite regression. You can always ask, well, at what point did you start going around the circle? That question is nonsensical because it has always been happening. So as long as you have a cycle, something that has been cycling over and over again, you can say, yeah, that is an eternal thing that's been happening over and over again. We already know that something must be eternal, and so that something would make the most sense if it were some sort of cyclic thing happen. I'm not saying that's how it works, but I'm just saying that that's a working model that shows there can be a collapse of the universe mathematically and through physics, right? Okay, so that being said, let's just suppose that's the shape of the universe. This is the beginning, and this will be the end of our universe. I'll go into that. I don't think that that's the only universe that exists. Meaning, the word's been used, the word originally used to mean that included everything. Now we use the word reality to mean everything. But before, the word universe used to mean everything. But now we don't use the word that way anymore. Words change over time. So now we use things like universes. There can be more than one. So there can be more than one universe, meaning there can be another universe that also has an expansion and it has its own rules or laws, or maybe the exact same rules and laws, and maybe it has a different ending. Maybe it rips apart. Maybe look up the Big Rip if you're not familiar with that. Or maybe it expands on forever, so forth. I'll get into that later, but for now, let's just look at this linear time of beginning, expansion to end, and then a collapse. How does this happen? How does all this form? Way down here, we have the most fundamental particles actually we have some unstable particles that make forces and stuff exist. And they begin to be right above the Planck time. And these we call these like virtual particles and other things like that. We recently found, like, for example, the Higgs boson. At least we think it's the Higgs boson. Unfortunately, it's not as predicted. It's not the string theory's calculations of Higgs boson was not correct, and neither that is of what its weight and everything should be. Neither was the Standard Model. It was somewhere in between the two of them. What's interesting is my theory of how the world works is conceptually somewhere in between the Standard Model and string theory, which is interesting because I think mathematically, once we work it out, that the math should make a prediction that there should be something like the Higgs boson or whatever you want to call it, making up that field to help explain the background radiation and the things of the universe within our universe, that we understand it, the different fabric of space. What exactly is that? Why is the universe expanding when it shouldn't be? Like, based on the mathematics and all that kind of stuff. There's a lot of different. So I don't want to waste time going into all this different stuff that is kind of necessary to understand. But hopefully, for those that are watching, already understand all that. But just to make it simple, basically, the universe is expanding at an accelerated rate, and that mathematically would be impossible based on what we know about the universe, unless there was some sort of other force out there, like dark energy. And then other things like dark matter for different things like atoms and stuff, and how some funkiness within galaxies and why galaxies have the spin to them and stuff like that, the turning. But one thing that we see is that there's particles that seem to like pop in and out of existence, right? That's what it seems like to us. From our point of view, they seem to be pop in and out of existence. I'm going to explain that phenomenon and why that phenomenon is that way. based on my theory. Sorry, my throat's a little bit harsh. I think I've had like a slight cold the last couple of days because my voice has been doing this and I haven't been yelling or nothing like that. So if you have what's underneath, does anything exist beyond Planck space and Planck time? This means like Planck space and Planck time means that time breaks apart, space breaks apart. I'm going to explain like what time is in my theory and what space is exactly in my theory, because it's different than what a lot of people think space and time might actually be. But in my theory, way down here we have these things called purons. I'll draw them with blue. I'm drawing them very big, just to make sure it shows up on camera. So we have all these different types of purons. And each puron is like its own little packet of information. And it has different ways of how it moves, different ways of how it acts. But each one is fundamental in how it moves and how it acts. You probably can't see the color difference there. Some are brown and some are blue. But let's say one puron moves this way. Now what's important about my view is that beneath Planck time and space, this is well, I'll just say it now and I'll explain it how it is. But basically everything above this is a projection from underneath here. So this line is flat for a reason. I do it flat for a reason because this is all flat. This is an actual flat land. True flat land, two-dimensional space. So it's a flat, infinite flatness of information being processed. Logic is also eternally part of that. It's some eternal flat plane of information. Now some of you right there are like, whatever, this is crazy, I'm done. But that's fine, I understand that if you're done already. Keep in mind that the holographic principle is a scientific, acceptable theory within physics of the universe. The holographic principle basically states that there is a flat existence of information that is very similar to a hologram, meaning that within every section of it is every information repeated over and over again. That's how hologram works. You can take a hologram and cut it in half, and it will still work. It'll just get blurrier and blurrier and blurrier the more you cut it in half. Meaning that within every section of that hologram is all the information to make that picture, to make that three-dimensional image. So you have a flat image, right? A flat piece of film type imagery. And from that, if you shine light through it correctly, you can make a three-dimensional image appear in front of you where you can actually move and walk all the way around it. And it's created from a flat piece of something, like a flat imagery, right? A bunch of information contained on this flat, that's how hologram works. And it projects an actual three-dimensional object like my hand that if you were to walk around, I'm going to turn it, or you can put it on a turning stand and you can see all angles of it. Yet, all the information is contained on a flat piece of film that is projected up, and what you see is a 3D hologram, right? So the 3D-ness is an illusion. And in the holographic principle, which is an accepted theory within physics, is just like that you have this flat plane information, and from that flat plane information, the 3D universe that we experience, the fact that we think that we're 3D, that everything around us is 3D, that there's up, down, left, and right, all this space actually exists, is an illusion. It's not, it's a projection, right, from this information. Well, my theory is a little different than the holographic principle. Instead, we have this, underneath Planck time, we have this big, flat, infinite plane. Now, it's not sideways like this. It would be actually, like shaped more like flat like this coming out at us. Like if I would turn the paper out toward us like this, right? So it's big, flat, infinite. Now, infinite meaning it goes on in every direction forever. And this way, in two dimensions. And all of that infinite information is contained within that is everything that could ever be, informationally wise. It doesn't mean that you exist as an actual person there within this flat information, but the idea, the concept of you and everything you will do and everything you could possibly do within every we'll get into more because this isn't the true shape of the universe. It's actually different. I'll go into that in a little bit later, but for now, let's keep it simple. Everything you could ever do and ever would do is within the information. How is that possible? That's saying, well, does that mean that the information knows the future? I'll explain that in a little bit. No, it doesn't know the future. And that's where we're going to get to B theory of time. But like I said, our brains work in A theory of time, so I have to explain it first in a linear fashion, then I can explain it how it's actually B theory, and then how consciousness exists within that B theory of time. And why is it exactly that we experience a past, a present, and a future? And it's actually quite mind-blowing how exactly that works within this model. So let's say one Piron's going this way in this infinite flat plane of information, and another Piron is moving this way. Now, there is movement there. So it's not like movement altogether is a complete illusion. But the movement here is not something we can experience, right? We can't experience, life doesn't exist down here. This is this information. Life only exists up here, right? This is all information about up here and how everything is projected from this. And I'll explain in a second. So one Piron's moving this way and one Piron's moving that way. When they hit each other, going in both directions like this, depending on their property, what the property of this Piron is and what the property of this Piron is, will determine what happens to, like, let's say one has a spin, for example, and its spin is this way. And this one has a spin that's the opposite way. And then when they hit each other, let's say it cancels each other out, and they just kind of bounce and go back the opposite way they came. But what if one has a slight different spin than the other one, and it makes the other one kind of veer off like this, and this one right here kind of, so when they hit each other, they hit each other right here. This one veers off this way. It causes it to go up that way. And when I mean up, I don't mean up. I mean off in a direction on a two-dimensional plane. So if looking at a flat plane, it goes off right or left or whatever, but at a slight angle. And the other one shoots out at a different angle like this. As all this is happening, it runs into a different Piron that has a different property, causing all these different movements to happen, right, within this plane, within this flat plane. And so you have all this bombardment, all this information being handed around. Now what happens is every once in a while, we'll come up here, and this is how I'm explaining how you get these particles that appear to pop in and out of existence. Why is that? The reason why that is you have a Piron that's right here underneath Planck time, and another Piron that's right here underneath Planck time. When they connect, when they interact with each other, the way that their properties work is that it causes a type of temporal upwardness. Because remember, this is a flat plane information. So there's no such thing as up or down. There's left and right, forward and backwards. It's two-dimensional. There's no up or down there. Just like in a hologram, you can say that in a hologram there's technically an up and down because it is a film that technically has a diameter. But there's no like upness, like true upness way up here. This doesn't exist. So what happens is that if one of these two particles have two different properties that allow them to interact in such a way that their spin would like theoretically, logically cause an upward movement to happen, because they can't actually move upward, it's impossible because they only exist in this flat plane. This flat plane information has always existed as a flat plane information. It can't change. But if logic, because logic is part of this system, then if they come in such a way that the forces, the way they're spinning and hitting each other, should cause an upward movement. Like if you take two marbles, for example, and you spin each marble at each other, if they're spinning at each other just right, they'll pop up, right? They won't just bounce off each other or bounce like this. So meaning that if I had a marble here and a marble here, and I make them hit each other, they run into each other, and this is where they run into each other. They bounce off each other. Maybe one goes this way, one goes that way. Sometimes they'll bounce like this exactly. Sometimes they'll bounce like that. But what will only happen if you put spin on them. Now, if you put a spin on each of these marbles and they're spinning different directions, like this and this, and they hit each other, they can actually hit and cause each other to pop up into the air. Well, the pyrons have this spin property. The problem is, though they have that spin property, it's impossible for them to exist somewhere that is not real for them. Because there is no upwardness. Upwardness doesn't exist. Upwardness is an illusion. And this is what causes that illusion. So, because it violates the very nature of their existence, their essence, to actually bounce up. So if these were actually two marbles and they had this type of spin to them, right? They had this type of spin to it. When they hit each other, they'd pop up, right? They're spinning just right. When they hit each other, boom, they'd pop up. They let's say they both have that spin right now, and they hit each other. Well, because if it were that they existed in some three-dimensional world, if there actually were a three-dimensional world, then they would pop up naturally, just like two bowling balls. Now, there's a lot of evidence to suggest that indeed time is an illusion. Truly, like Einstein said, the past, present, future are illusions. That time is truly relative, but why? What exactly does that mean? How and why is time relative? And my theory explains that. My idea of the universe explains that. I'll go into that. In fact, I'll put up here, if I don't forget, time, and then frames. Like a video game. This is just for I don't forget, because I want to talk about that. It's very important. So because logically they can't go up, but logically there's a force that should go up, a virtual force is created and it goes up this way and extends into our known world, the world that we can measure. But that particular virtual force is so unstable that it exists for a very short amount of time. So it goes boom, and then it kind of dissipates and comes back down into this world where the information is retained. But here we only seen it for a very short amount of time. So it's really hard to detect that virtual thing, and it's really hard to know exactly where that virtual particle will be at. We'll call it a particle because when it needs to be a particle, it'll appear as, when we try to make a measurement, this force, right? It's simply a force though, right? It's an actual like wave, so to speak, because it created this temporal wave. And we see it from our point of view as, hey, this thing seemed like it popped into existence out of nowhere. Like it just, this we call them like virtual particles, for example. Some virtual particles appear to pop in and out of existence. And you can look that up. Just look up particles that pop in and out of existence. You'll see there's tons of physicists that have mathematical equations that say these things exist. They observe them in some way to be popping in and out of existence. Well, how is that possible? This is how it happens right here. In my model, this is how it happens. So it creates this temporary force, this force that pops up and comes down, and when we take a measurement of that force, it appears to us like a particle, right? And so we go, oh, so this virtual particle is only existing for the short period of time, and from our point of view, since we can't see any of this world beneath here, we can't see the flat infinite information. In fact, we never will be able to see it. We'll never be able to measure it. We might be able to measure its influences here, which we're already starting to do, but we'll never be able to measure all this stuff down here. Now, there's many different things that happen before you have this, but first I just want to explain this very top layer here. And what I mean by top layer, it's not because it's flat world, it's not really a top layer, but it's just easier to try to explain it in a vertical way, even though it's not actually a vertical thing that happens. It's all happening on a flat plane like this, and these things are interacting, and then there's enough interactions, they bubble up. Somewhere, even below this, Planck time, this is actually where, first I want to explain this here. I mean, this is how it ultimately happens, but there's this big space here that I don't have a name for yet. But that space beneath Planck time, and then this line here would be the actual where all the purons live. So this is the infinite amount of information. This is like a temporal world, so to speak. It's where very unstable particles live for such a short amount of time that we'll never be able to measure them. That's how short because they're beneath Planck time. We'll never be able to measure them. So what happens is, take these two exact purons again, come back down here, they pop up, they create this field that comes up, this virtual particle right here, and it's very unstable. And it lasts such a short amount of time that it'll dissipate if it doesn't interact with something else. But once in a while, another purine over here and here interact and they create another force, another type of virtual force particle, and they both hit each other right here, and they either negate each other and dissipate, or they have the right properties that they almost combine together and make a new, bigger type of particle, so to speak. If you think about them as particles, even though they're not, but they're like packets of information, but those packets of information like cling onto each other and they get bigger. And now you have a more stable particle. So right from here, I'm making this very simple. There's actually a lot of stages here, but we're just gonna make it look like a few stages. Now you have a more stable particle that exists on this plane right here. Again, beneath Planck time, so we'll never be able to see it. And then sometimes over here, other purons interact and they create another force field that comes up here. Well, not force field, but another force comes up here, bam. And that connects with that super, and it becomes even bigger. Now it's a lot more stable. And then you have another one over here, like this, and then these two are moving together, and they both collide, and they create a bigger particle, so to speak. Again, I'm calling them particles, but they're not actually particles. They're virtual particles. Meaning that they might. It's easy to kind of see them as particles, but more they're like packets of information. Now that's still beneath Planck time, but when another one of these interact, then it pops up here, and it pops up for just a second into our world, where we can actually take a measurement above Planck time. It becomes stable enough that it exists long enough that we can actually take a measurement of it. And when we do, we go, whoa, where did it go? It's gone. As if it popped in and out of existence. And then we can see that it actually has a waveform to it. It has some sort of wave pattern to it that seems it can be in any of these. It can never exist. It can never exist here. We can never measure it here once we measure it here. But we know that if we measure it there, it can be in any of these places. And so then we can go, oh, well, because of that, then it's literally existing in all these places at once where it can actually be. No, it's not. It's only existing where that probability wave is at, because it's popping, not in existence, it's dipping in and out of our space and between this space here, which is still not, well, it's the beginning of 3D space. It's like the rudimentary 3D space. So all this right here, this is rudimentary 3D space. Right? So time doesn't quite exist there like it does here, but there is some sort of 3Dness. There isn't like an up and down, left, right, and all that kind of stuff. So that's the beginning of the creation of three-dimensionalness, of 3D space, of space as we know it. Up here, though, we also have time in such a way that is very different than here and very different than here. Here, time is almost as if it doesn't exist. I mean, obviously, time exists there in some way because there's movement. It's a form of abstract time, kind of. Because, yeah, there is a form of movement of information interacting, right? Information is interacting in some way, and that's a form of movement, right? Because truly, without time, time is the interpretation of movement, right? So without movement, then you cannot have time, since time is the measurement of movement. So if there's no movement, or if there's no time, there's no movement. If there's no movement, then everything is static, meaning there's nothing happening. If that were true, then this would not exist, because all this information would just be static and doing nothing, not interacting whatsoever. Therefore, you never have this world here, the rudimentary 3D world, and therefore you never have the world we exist in. And so you just have a static somethingness, right? It might as well be as good as nothingness, because we wouldn't be here. Nothing would be here except for that static information. So there's a form of movement there, but it's not time as we understand time. And I'm going to get into why that is. Why is time so different for us? Why does time exist in our universe so differently than it does here? So now we have these particles here that are popping into existence for a moment, seemingly popping out of existence, but sometimes they interact and they create a more stable particle. And that particle and another particle interact and they create a more stable particle and a more stable particle and a more stable particle until we get to our fundamental particles, things like electrons, things like photons, things like gluons, and all these things that are more stable. Gluons aren't quite, I think, well, quarks rather. So things like, quarks and then eventually, when you have different quark combinations, you get things like neutrons or protons. But you have these fundamental things like the quarks, like the electron, like the photon. And then from their interactions, you get other particles. So what is a neutron? What is a proton? A neutron and a proton, unlike an electron, are made of smaller parts called quarks. And if you have they're like in a triangle formation, let's say you have two up quarks and one down quark. I think that is a neutron, I can't remember. And you have two down quarks and one up quark, and now you have a proton. It's one or the other, I can't remember. It's not something I ever dedicate to my memory because it wasn't important to me. I just know that they're opposite, and one's a neutron and one makes a proton. And all it is a different configuration of quarks. That is up quarks and down quarks. So when you have a different configuration of them, you suddenly get very, very different properties that don't exist otherwise. So within the down quark and up quark, you don't really have this idea of some neutral force, or, you kind of do, but not like a neutron. You don't have the idea of a proton, like a positive force, right? But once these things combine, now you do have a neutron, now you do have a proton that have their particular properties that make them act the way they do, that either repel or attract other things like electrons, and can make, form together and form like a nucleus that can make electrons orbit around it, and that create different types of heavier elements like atoms, like, things like lithium and helium and oxygen and hydrogen and things like that. Then eventually those things interact in certain ways, and you get things like suns forming and whatnot. And then you get the whole universe. So then as it begins to expand, you get the whole universe. So from this point right here, that's all this right here. So if you want to think about how did the Big Bang happen, it happened right here by all these interactions within this world. So within that singularity, which is, we'll make a big circle right here, there's this other part right here, which I'll again draw in blue, which represent this area here. So within that expansion of the Big Bang, the part that we can't measure, where our math breaks apart at the singularity, right here, that very beginning of the expansion is right here, the part that we can't measure, the part where our math breaks apart. And this is like a bunch of interacting particles that once they start interacting out here, then we can start making sense of it mathematically with our math, right? And it starts expanding out and it starts becoming all the different particles that we know of. And then they start cooling down, and then suns explode, and you get heavy particles like iron and whatnot as the universe expands out. And then you start getting galaxies forming and all that kind of stuff, and then eventually life and so forth. That's the linear way of looking at it. This is where it gets a little bit weird. I'll move the camera back here. So this is where it starts getting a little bit mind-blowing when you get into the B theory of time of all this. So how can you have a infiniteness when we are clearly not infinite? We have a beginning. We remember our beginning. We remember our birth. We remember other people's births, so forth. So why does it work that way? Then I'm going to get into the actual structure of the universe being very different than this, right? I'll probably end with that, so the video is not too long. And then if you guys are interested in knowing more, I have a lot more in it. But once you see how all this works, you're going to see how there can be life after death from a naturalistic, mathematical point of view, right? Doesn't mean that it does exist, just saying it could. And I'll kind of relate it to video games a lot because you'll see how it is very relatable to video games how a video game works if you know how they work. So now you have a better understanding of how these particles can seem to pop into existence. Now understanding this, what drives all this? This infinite information. This infinite information drives all this to happen. It's what gives the properties their unique properties. It's what makes the electron makes the proton. It's what makes all this stuff come together and work in a logical fashion to where it comes together in a certain way to where it starts forming proteins on planets. And then those proteins start forming together into actual cells, and those cells start forming together into more complex life forms. It's still, you can see how it's repeating. It's like a fractal. It repeats a pattern, right? So in the same way that you have two up quarks and down quark interacting and making something different, a whole new property that didn't exist before, that is a neutron or a proton. And then in the same way, let's say you have, when you have different neutrons and protons, electron interactions, depending on how many electrons are orbiting a nucleus and how many nucleus or how many neutrons and protons are there that have this orbiting of electrons and its force field, that creates an individual kind of atom, be it lithium, be it hydrogen, and so forth. And then once you have the stable elements that you probably learned in chemistry, once you have those stable elements, what happens when they interact? You get things that we call molecules, right? So when you have H2O, 2 hydrogen and 1 oxygen, again, another triangular type pattern, and it makes a triangular 3D type of, that's what water is. Water is a big triangular type 3D structure on the microscopic level. And it consists of a bunch of combination bindings of H2O, right? Now when you have H2O2, you get hydrogen peroxide, which has very different properties than water does. But all it is one molecule different with a different structure of how it's linked together. So if you link together 2 hydrogen atoms and 1 oxygen atom in a triangular type of structural pattern, you get the property of wetness. Here's what's weird. Where does wetness exist in hydrogen? Where does wetness exist in oxygen within that actual atom? It doesn't. Wetness, that sensation of water and swimming and the sensation of you getting wet, doesn't exist within the hydrogen by itself. And it doesn't exist within oxygen by itself, right? Within the atom itself. So where does it exist? It exists when you have that unique structure. It creates a whole new property, the property of wetness, the property of water, and it has that whole new buoyancy now that water has that only exists when you have that unique connection, that triangular connection. And in the same way, when you combine certain proteins and stuff together, you start to get a linkage, a whole new property that exists that takes on properties of movement, of connecting together. We already know that things move and connect together, just like electrons, right? They'll bind and sometimes they'll fly off an atom, and now carbon-14 will come carbon-13 because it loses some of its ions and stuff, right? If it gets bombarded by radiation, you can actually change. Also degrading, most all elements degrade, like atoms degrade into lower atom or lower forms of its structure. And so you have this degrading property, its half-life. How long can the atom exist? Now, a photon electron is said to have no half-life. They should be able to go on forever and ever. I believe the electron is that way. I know the photon is said to be that way. So now you can see a kind of similar pattern with cells. So when you have these different proteins all come together in a unique way, you get cells. And then when you have a bunch of cells starting to combine in a unique way, you get a more complex form that has different properties. And eventually, if you get enough cells coming together and forming, first, the DNA forms from the protein. So you first have these protein strands, and these protein strands, they start working together in weird ways, and they start creating like DNA strands within a cell, right? They create a cell that has this DNA in it, this information in it. Well, where does the information come from? It comes from here. It's already existed forever. The eternal information that's been always interacting. That's where it comes from. And this is driven logically. Now again, I'm talking about it as if it has a beginning, ending, but it doesn't. But we'll get in that in a little bit. So it comes up, and it is what drives all this. It's what tells how things move and how things work. It's what drives the logic behind everything. It's what says that the these particular things will form together and make a protein chain, and that those protein chains will come together and make a DNA chain, and that eventually have a basic form of a cellular life form, right? They'll form a cellular wall and all that kind of thing. And then you'll have different cells coming together, forming more elaborate type of life forms. They have multiple cell, that is a multiple cellular organism rather than just single cell organism. And that is just one single cell versus multiple cells. We're a multiple cellular organism. And it drives that evolution, if you want to call it that, right? Because this is all evolution already. Change. That's all evolution is, change. You have change of atoms, right? So when water didn't exist in the universe, and then you have the hydrogen and oxygen being attracted together by the rules that are already down here that tell everything how to work. This is the rules between all the laws we understand. It's what make all the rules that we understand in the natural world, right? This infinite information, infinite logical system. So what would we call this? Would we call it God? No, it doesn't think. It doesn't see, it doesn't hear, right? It doesn't listen, meaning it doesn't hear you. So you can't talk to it, but it is eternal, it is infinite, and it does program the universe, so to speak. Makes everything what it is. So basically, what does it say? If you look at the whole picture so far, what can we call reality? It's a self-programming universe. In a sense, you can call that a self-programming universe. So this differs from like a simulated reality. Because although reality is being simulated by this eternal information and being programmed by it, it's not being programmed by a brain, by some species from another planet, or from some supermind that has always been there. It's not being programmed by consciousness. There's no consciousness here. The idea of consciousness exists here. How consciousness should exist here. The idea of it exists informationally, but it doesn't actually exist there, right? So then what we have is we see this kind of pattern repeating itself when we get life and things like that. Okay, so that's looking in a linear way. Now, let's look at it. This is what time it is on the clock, but on the camera. By the way, this is being filmed with the Samsung Galaxy 8. I don't get paid to say that shit, but I'm just saying it's a really good phone. It does a pretty good job in low light situations and bright situations, and also changing of like moving from, let's say, a dark alley because it's very shaded from the sun into the sun area. Just really good camera. I made a video for like a half an hour. I filmed it with the phone underneath a hot tub. The water was pretty hot. It was a hot tub. And so it's in hot water, and I filmed for like 30 minutes under the hot tub, and then took it out, let it dry, obviously, before I plugged it back in to charge it, and it never stopped working. Works fine. So it's great. It does great underwater video. Better underwater video and better underwater sound than the GoPro that I have over there with its waterproof case and everything. So I have the latest GoPro in it, and this thing is better than that. So save your money, buy a Samsung Galaxy 8 Plus, and you have a phone and video game system all in, and a great camera all in one, and waterproof, and it's cool. Okay, anyway, just a little side note there. Just want to say, you can take some really good footage with this thing. It's really awesome. Like I believe you can film movies with these phones. There might be some graininess and some of it with the darkness. But anyway, okay, that being said, what's the shape? Before I get into the eternality of the universe, the B theory idea of time. Actually, let's go through the B theory of time with this simple shape first, so then you can understand the actual shape of the universe, in my view. So that way, it makes better sense that way, I think. So the shape of the universe here, kind of like a football. We'll call it the football universe. So as it seems to have a beginning end, as it expands out and then eventually starts collapsing back down into a singularity. Now, this would actually be impossible. That is, if you take the idea, the concept of the standard model, and you only take the idea, there's many different ideas within it, but if you just take this one simple concept that there was a singularity that existed outside of time and space forever and ever, right? Obviously, if it's outside of time, then it's always been there, right? But some people say, well, it's outside of time, so it's not. Some people say it's always been there because it's a tense word. It doesn't really matter. It's outside of time, right? So it has no way to change. Without movement, a static object has no way to change, right? It can't just spontaneously change. It has no way to change. And so to say, oh, there was a singularity that's been stable outside of time, then it would remain stable outside of time. It would never expand. Something would have to act upon it to make it expand, right? But anyway, so we have this like expanding universe with the beginning of time. So imagine instead of having a beginning and expanding and having an ending, or just expanding out forever, whatever is the view you have. But in my understanding, this is going to be the end of our universe. It's going to collapse back onto itself, and then something else will hit it, and it's going, because there's many different universes, and there's actually Googleplexes of them, and something else will hit it, and it'll cause another Big Bang, and a whole new other universe will expand with maybe different properties and different life forms and so forth. Maybe no life forms. Everything that could be possible within this information that could exist will exist. But only what's possible to exist will exist. All right, so with that being said, I'm gonna have to go through B theory of time first before I go to the shape of the universe. Okay, so with B theory of time, imagine that you have all these slices within space as we move through time. Of course, there'd be a lot more than this, but I'm just kind of dividing it up to where it's visible on the camera. So as you have these different slices of space, and if we think about it as a linear way, then it began to expand, and we're existing right here in this slice of space-time right now. That's the present moment. Of course, we're already not there anymore. We've already moved to a different slice of space-time because time's always moving, right? But if we can freeze time, boom, that's where we are right now, bam. And then it continues to expand. But each one of these slices of space-time represent a different slice of space and time. Now remember, according to Einstein, and it has not been proven wrong, and it is a falsifiable thing, and that's why it is an acceptable and used actual theory of science. And when we say theory in science, we don't mean theory as in, oh, it's something that could be. No, a theory in science is not a hypothesis like you might have. Like you might go, hey, I have this hypothesis, or I have this idea, and maybe it's real. No. It is something that has been proven over and over again with experiment upon experiment, and not only that, but has predictable power, makes predictions before we find it, and then we prove those predictions. So Einstein made predictions based upon his mathematics, not him, his theory. He made a theory with mathematics equations. Those equations made a prediction, and that prediction was that light has to be a constant, and that time has to be relative. That's crazy. At the time, that's totally insane to think about. That time is relative? What do you mean time is relative? Time should be the same for everybody, but it's not. The time is not the same for everybody. And if you want more information on that, just study relativity and stuff, and there's some YouTube videos that will break it down in a more easy way to understand without mathematics and all that. And the twin paradox is a really great one to kind of start to try to understand what it means for time to be relative. But time is truly relative, meaning that my past and your past are not the same if we're moving in different parts of space and time and things like that. So what if, instead of there being a beginning and ending of this shape of the entire universe, of all these slices of space-time, what if they've always been there? What if all this stuff I just explained has always been happening? It's always been there. In other words, the universe is a static object. It doesn't move. Then you say, well, how does time exist? It doesn't. It's an illusion. Within the B theory of time, time is an illusion. It's truly not there. Because the entire universe, from its beginning to its end, or from its beginning to whatever its end should be, if you believe in some expansion, I believe it's going to be a collapse. In this shape of the universe, instead of it having a beginning and expanding out and collapsing and having an ending, imagine that every slice of space has always been there. So the formation of the fundamental particles, the formation of suns and things like that, the formation of galaxies at some later time, the formation of supernovas, or rather the event of supernovas happening, has always been there. It's always happened, everything from beginning to end. Don't think about consciousness yet. Don't even think about life yet. Imagine that life doesn't exist right now. To make it easier. And this entire universe has always been there, static, non-moving. Okay, So if that's true, if it's always been there, this static universe, non-moving, how do we move? How come we have a past? We remember a past. We experience the present of you watching this video right now. And we can visualize a future. We can even calculate the future in some ways with mathematics, right? We can make predictions of exactly where the sun will be 10 years from now. We make a prediction exactly where the planets will be 10 years from now. We can make a prediction and say this exact day and time that the next eclipse is going to happen, right? We can do that. So that's so awesome to us. We're like, there has to be a past, present, and future. We experience it. How do we experience it? Why do we experience it? If this is true, and the universe is static and doesn't move, all this up here is static and doesn't move. It's always been there in a static way. It doesn't move. And this is the only thing that moves down here, the infinite information. And the movement is abstract. The movement is information interacting. And this in-between space is also movement, but it's movement that we don't understand. Right? It's not movement in the way that we understand movement, these interactions. But up here we have movement in the way that we understand movement. But why is there that movement? What is that movement? What is that time that we experience when we're here? So, this is where it gets kind of cool. We are the movement. We are the time. We are the reason that time seems to exist. If conscious did not exist, neither would time, neither would movement. Because there is no time movement. This is all static. It's always been there just like that. That whole universe has always been there. From the beginning to the end, every single thing that could ever happen has always been there, non-moving, static. Now, a way to understand this idea, this concept, before I get into how mind, our consciousness, is what actually creates the movement. And consciousness, again, is created by this logical eternal information interacting, right? It's what makes it possible for us to have this thinking ability. But we have always existed in a way as a thinking thing, but because we are created by this as an A consciousness, see, because the logic exists here eternally and everything must work logically, consciousness can't work in B theory of time. It doesn't work. It falls apart. It doesn't logically make sense that you can have something that has always been there, is static, yet is thinking. Because if you're static, there's no movement of electrons, no movement of nothing. How can you think? Thinking requires abstract movement to be able to move from one thought to the other. If you don't have that movement, that abstract time, if you're truly static, if you, as a conscious entity, were part of B theory of time, you'd be static and non-thinking. You would not be happy, you wouldn't be watching this video right now. And the eternal logical processing information makes this so, right? It's not that it knows it, I want to say it knows it, but it doesn't know it in the way that we know things, right? Because it's not conscious, but it has no consciousness itself. But because of the logic, because of the way that the information works, when it creates, so to speak, when it programs a consciousness, the consciousness, when it exists within the static universe, has to exist in a theory of time way. That is, it has to see things from its point of view as though it's moving linearly. But why does it see it that way? Well, one, it's not that things are actually moving. Again, it's that you think they're moving. And why do you think they're moving? Because you are programmed by this logical system to see things and feel things in the present. And you're also, biologically, you have memory, right? You have this mechanism of a brain that gives you memory. And because you have a memory, you think there's a past. Because you have this memory of the past, right? So it's the ability of the mind to remember information that's taken in the present and storing it, that you go, oh, okay, I have a past. Past exists. And because you can think about the future, and because the future already exists, you can make accurate predictions of it. Because all this is already there. So where the eclipse will be is already all there. So all you're doing is you're figuring out the math it's there already. You're just figuring out, from your point of view of existing right here, right now, you're looking at how things appear to be moving, because we're constantly moving through time, so to speak. We're not through time, but through the static universe. So the analogy I wanted to give is, imagine you're watching a movie, an old school movie at the theaters, and it's on a reel, right? That reel, if you were to undo the film, what is that film? It's a bunch of squares. What are those squares? They're actually individual photographs, right? Not a photograph like one you take, they're more like a negative, but they're photographs nonetheless. They're individual images. Now, when each of those images passes through, right, that's a static object. If I unroll that film and tape it on the ground, it's a big, long thing of sequence of images and some logical progression that moves one way to the other, right? About 24 frames. That's how it's usually filmed, 24 frames a second. So this is where you're going to get to the analogy when I get into time and how the twin paradox works, but I'll get into that in a little bit. So imagine you have this unreeled movie out in front of you. If you just look at it as a whole, you don't see a movie. Let's say you had the brain power to focus on every individual image and in one sequence, right? And you can see them all simultaneously. You had that ability. You had some special technology, hook your eyes up to, and you can see every image simultaneously. You wouldn't see a movie. But if you were to put the film on the ground and look straight down at it and walk at 24 frames a second, what would you see? A movie. Right? If the images are blown up big enough to where you can look down and see them, and you can walk exactly at the speed to where, as you're walking and you're looking straight down, and you have a special pair of glasses on or some special block that only allows you to see that one image at a time, and if you were to walk at the right speed, that after you have walked at the right speed, which would be a very fast speed, so let's say you're like laying down, like so this is you, and this is your head, and this is your feet, and you're laying down like this, and you're on some sort of propelling system that moves you fast enough to where you looking down, you're seeing 24 images in front of your eyes per second. So boom, 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 boom. And as you're moving across these frames, what do you see? You see a movie. No sound, but you see a movie. In your eyes, it'll look just like a movie. You ever did the flip thing where you draw stickman on the corner of your notepad in school, and you flip it, and the guy's like going, yeah, he's moving, right? That is a form of movement, right? But it's an illusion, because the guy's not moving anywhere. You're seeing individual frames that are one taking place over the other, and when you flip through it at the right speed, and if you flip it too fast, it doesn't work. Too slow, and it looks choppy and weird. But if you flip at just the right speed, at about 20 frames a second, 24 pages a second, you get a nice, perfect, smooth, awesome animation. So that's how the universe works with your mind. So right now, we're all moving consciously, right? Because the body is an illusion. All this is an illusion. None of this actually exists. It's not solid. And that's a physical fact. Scientific physical fact that nothing is solid. I know this might be mind-blowing for some people, but you can do all the research into atoms and stuff like that. Where is the solidness in this pen? I touch it, it feels solid. My finger doesn't go through it. Why doesn't it go through it? Not because it's solid and my finger's solid, that's not why. It's because the molecules that make up my finger and the molecules that make up the pen and the atoms have a repelling force of electromagnetism. And electromagnetism is why you don't fall through the ground, because electromagnetism is stronger than gravity. So gravity is pulling you down to the earth, right? The earth is like this, and you're on the earth, and it's pulling you down constantly. If electromagnetism were weaker than gravity, you'd be pulled right through the earth and be squished and dead. You'd just be flat like a pancake. But because the force of electromagnetism is stronger than gravity, and there's the electromagnetic force of all the atoms on the earth, the electromagnetic force of your feet, gravity can't pull you through the earth, so you stay stable and you can walk on the earth. The same thing with this pen in my hand. The atoms repel against each other. Now, an analogy is actually a really good analogy because it's very similar. Magnetism and electromagnetism are related forces. They're actually derived from according to what we understand, from the same force. Only one we can't explain right now is like gravity within this unified theory of forces. But electromagnetism and magnetism are all part of the same force. We know that now for sure. So magnetism is a good way to explain this. Take two big magnets, really strong magnets, or two even smaller neodymium, like number 4 and number 5 magnets. Number 5 being, I think, the strongest ones right now. And if you take them and put them to where they repel each other, go like this and try to make them touch. They can't. You cannot make them touch, but it goes like this. Boom. You can visibly see they get within an inch of each other if they're strong enough. They get within an inch of each other and they push each other apart like this. Bam! Bam! Use all your might and just go like this, and it bounces your arms away. Bounces your arms away. You can actually get a workout with it. Bounces your arms away. I've done this. It's really cool. And it always fascinated me as a kid to see this with my own eyes. Like, what's making that happen, you know? And it's the negative forces, the forces repelling against each other, The same thing is happening on a microscopic scale. You can't see it with your eyes, but on a microscopic scale, the magnets in your finger, the electrons, all the electromagnetism of your atoms, electromagnetism of the pin's atoms, are repelling every time you hit it. So what causes a sensation of touch, though? Right? That sensation is caused by your nervous system. You have nerves at the end of your finger, and when the electromagnetism interacts, these fields interact with each other, which boom cause that repelling. Nothing ever actually touches. The atoms in your hand never even come close to the atoms in the pin. In fact, there's more space between the atoms in the pin than there are atoms in the pin. So if you can become microscopic and go into this pin, you would see more space than you would see atoms. The atoms would be so far away from each other compared to, that is, you'd have more distance between everything. So there'd be more emptiness in the pin than there is actual atoms in the pin. So you say, okay, well the atoms are solid. They're not, though, because when you go into an atom and look into an atom, it's made of other stuff, and there's more space in that atom. If you're small enough to go inside the atom, there's more space in the atom than there is stuff, and there's electrons, protons, neutrons. If you go into the nucleus of the atom, there's more space than there are neutrons and protons. And you go inside of the neutron and the proton, and there's more space between the gluons that make up the proton neutron. Right? So you say, okay, maybe the gluon's solid, but it's not solid either. It's actually a wave. That's all it is. On top of that, though, if you look at things like the delayed choice quantum eraser, look at my explanation of how that works, it's because the reason why it works the way it is because nothing is actually a particle even. It's truly just a probability wave. And it only appears to be an atom or look like an atom when it needs to be. And this is where it's kind of like a video game. So how a video game works is the video game only renders the part of the world that needs to be rendered, the part that you're experiencing as the game character. So where your video game character camera is at, what you can see and turn around and look at and say in a 3D shooter, something that's way, way far away isn't even rendered, right? It's not rendered at all. Like things that are moving, enemies are just there. Especially in older games. You could sometimes in older games, if your PC wasn't fast enough and you're running fast enough, you can actually see the world forming around you, like being rendered. You can actually see it rendering. So you're running toward something and you can see stuff being rendered, the world being rendered. You can see it's like blank and it's just kind of like gray, and all of a sudden you see it being rendered. You see like the patches of texture and stuff popping in. They call it texture popping. And so it happens on games today. You'll see texture popping on games today sometimes, because it's not, I guess it's not designed well enough or properly enough to where you wouldn't see that happening, because it's, they're trying to do too much for the power of the PS4 or whatever system it's on, or your PC, whatever. Okay, so in the same way, it's kind of like that. The universe conserves itself for the consciousness, for the mind. But keep in mind, this is all static. It's not moving at all, right? Nothing's moving. Same thing with the video game. So the video game world, nothing is actually moving. What actually happens is it has a changing of states. So, for example, let's look at Mario. When Mario runs across the screen, he appears to run across your screen like this. He's never moving anywhere. Nothing's actually moving. Nothing's even moving on your screen. Rather, the individual lights on your TV screen are lighting up here, lighting up here, lighting up here, lighting up here, making it look like Mario is running, right? So An easy way to, if you want to see a very primitive idea of this, would be like one of those signs, one that's like in Vegas or something, like old school Vegas, or anyway, one of those old school signs where it has like the woman and she's kicking her legs like this, and it's literally in a neon sign, and there's actually 3 girls on the neon sign, but the other ones are turned out so you can't see them, and so her legs turn on here, then they turn on, so those 2 neon lines turn on like this, and then those turn off and these ones turn on, and then those ones turn off and these ones turn on. And as they go, it looks like she's kicking her legs like this. And that's just three frames, right? So if you have a lot more lights, a lot more frames, the movement will be more smooth. The more lights that are happening between that, the more smooth her legs will look like they're moving. Same thing with the animation. If you draw a running animation and you only use 8 frames, it can look pretty smooth. But if you use exactly 24 frames to make that person run across the screen per second, it'll look super smooth to the human eye, because that's how we perceive things. Everything looks very good and artistic at 24 frames a second. If you do it faster, it'll still look nice and smooth. But your brain is pretty much going to kind of see it as 24 frames a second. From what I understand, that's how the brain and the eyes work, and that's why that has been used in cinema for so long. But I have to go and look at that to make sure that's correct. Nonetheless, you have a limit of how much information you can process per second, like frames per second, so to speak. Okay, so how is it that this works then? So our consciousness is made to work in the present. And because it has a memory of the past, we consciously are moving through these frames. We have no choice but to. It's the way we're programmed. Logically, we have to move through these frames, constantly, always. And since we're all moving consciously through this static universe, we're seeing a movie play out in front of us. We're seeing everything happening right. You're seeing my arms wave around right now. You're seeing, the moon rise and set, whatever. You're seeing the sun rise and set. Can't see the moon totally rise and set. Well, sometimes you can see it in the morning. You're seeing cars moving, because we're all consciously moving through this static universe. So in the same way, if you're watching a movie and you're looking down and you move fast enough and the frames are passing in front of you, the illusion of time is happening, because you're remembering the images you just saw a second ago, right? So let's say the movie you're watching is of somebody getting shot and die, right? So you see there's 2 guys standing off each other, old Western style, boom, and shoot each other. So the first thing you see is 2 guys, right? And as you're moving along, you see one guy pull his gun out, and bam, he shoots the other guy. You see the other guy fall down. So as in your mind, you pause, let's say you would pause at some point, your mind remembers all those images it just saw of 2 men standing there. Your mind remembers they have guns on the holsters. Your mind remembers the guy's pulling his gun out. The other guy's pulling his gun out, right? But this guy's a little bit faster. Your mind remembers all that. So then he shoots the guy. Your mind remembers that. So if you pause right there and stop the movie, your mind remembers all of those frames it just witnessed, all those frames it just experienced, of the 2 guys standing off, talking, whatever, or they're just staring each other down, because they're probably not talking, not in Western, right? Staring each other down, and then boom, they pull their guns out, and you pause the movie, you remember all those images. And then boom, he shoots, you unpause, and the guy falls down, he's dead. Remember all that. And now the girl comes out of the bar, she's like, oh, she's screaming, and she runs over to the guy and she's holding him in her arms, You remember all that. That's all the past now, because you have a memory. So because we have a memory, we have a past. If we had no memory, you'd have no past. There'd be no such thing as a past. It wouldn't exist to you. All you'd have is what you're experiencing now, right? It'd all just flow into your head and go out like a hole, and you have no memory of it. It'd just be like, I experienced the now, and that's it. And so it'd be very weird, you got no memory. Conscious wouldn't work without a memory. So you are your memory, actually. You are your memories. If I were to erase your memories, you would no longer be you. You'd be you would, if I let you continue to live, but I erase your memory, you'd be something totally different. And we can even see this with people that have amnesia. They get really bad amnesia and they They forget their stories, a lot of documentation of this, where people who have had amnesia, people that knew them before and after the amnesia are like they're a different person. It's as if they're a whole different person. The personality, everything's like different. They completely change. But the amnesia has to be bad enough. Like almost like the incurable kind. But they end up getting new memories, so they end up developing another personality. Because you are your memories. If you lose those memories, then you will no longer be you. So that explains the past and the present. The present is something that you logically are processing, right? You are your own processing unit that this makes possible. And as a processing unit, you're taking information and you're processing it, right? Consciously. So if I get deeper into my philosophy, because all this is static, it's also an illusion. It's not really even there. It's all created by, it's a 3D illusion. None of it's there. It's not solid. Solidity is an illusion. The time that we experience is an illusion. Space is an illusion. 3D space doesn't exist. It's not really there. We're not moving anywhere. I know it appears like we're moving places, but we're not. It's all in our head. So we are the conscious processing unit that is consciously moving through a static universe, something that's always been there, forever and ever. Everything that can ever be has always been there, and we're statically moving through it. You say, well, that means that we're fated. Fate, then we can't make choices. Like, no, I'm going to explain why we do make choices, because this isn't the shape of the universe. It's actually different. So I'll need a different piece of paper for that. Well, I'll flip this one over. But so basically, you are consciously moving through the slices of space-time. We all are, and that's what gives us a unified experience. That's all, because we're all moving through the same exact static universe. It gives us this unified experience that we can agree on. Things are happening, but not all the time. See, with Einstein, and it's been proven and shown to be true, that if we're moving at different speeds and things, we might disagree on what time things happened. How is that possible? If time were real in some real way, how can we disagree on what time something happened, depending on how fast we're moving through space? Because time and space are the same thing. They're interlocked, and it's an illusion. So I'm going to explain how this happens, and it has to do with frame lag. So it's very much like a video game. So before I explain the actual way the universe is shaped, so that we can see how it is you're actually making choices. And this is really cool because it shows that you are not determined to do what you do. I mean, there's some things that you're determined to do, like you have parameters. There's certain things I can't fly like Superman right now. I have parameters. There's certain limitations I have right now that don't allow me to have full freedom. But I do make real choices, and I'm going to show you how you make those real choices based on the actual shape of the universe. If this were the shape of the universe, you would not make choices at all. You'd just be flowing through one possible direction and only one possible. You only can make one. There's only one way you can go. There's no way. There's this one straight line, and that's the only line you can take. And so you're not making choices. You're not really. Your choices would be an illusion as well. But that's not the shape of the universe. And I'm going to show you in a little bit why that is. But so let's go with time. So time is like a video game, right? Because if we are moving through a static universe, just like a video game character, because that's what video game characters do. The video game character that you're controlling is actually moving through a static universe. Everything's already there. It's already exists programmably, and it's only being rendered for you as you're moving through it. It's not really moving. Nothing's really moving in the video game. Instead, things are changing states. That's not movement. Just like the girl's legs, that's not movement. It might kind of appear like movement, but it's not. It's an illusion, right? Her legs, there's no legs. There's 3 individual lights, 3 individual images that are turning off and on, changing states, giving the illusion that her legs are going up and down. But it's a very primitive illusion, and you can see the illusion. It's so primitive. And if you have those like signs with like the big bulbs on them, and the bulbs will like change colors and stuff like that and give you the illusion of movement, and words will come up on the screen and disappear, you can actually see the illusion, right? And it makes the movement look weird because you can see the illusion. But on this camera right now, you can't see the illusion, right? Can you see the illusion? The exact same thing is happening right now on your TV screen, or on your computer screen, or on your telephone, on your tablet. Whatever you're watching this video on, most likely it's going to be on a tablet or a phone. I know that because the analytics shows me on YouTube that most people on YouTube and everywhere now watch on their tablet or on their phone. People hardly use their laptops and stuff anymore for that kind of stuff. It's interesting that I've been looking at analytics over the years, and I've been seeing a decrease in PC use and an increase in mobile use. Anyway, whatever device you're looking at this on, that movement right there is not movement. It's an illusion, what you're seeing right now. That's a fact. You just can't see it. But there's a bunch of individual little lights that are in your phone on the actual screen. If you take a loupe, a 60 magnifying loupe, a magnifying glass, and look at your screen, you can see the individual, like little, I don't know if they use LED screens or what the phones use, but you'll see the individual lights that light up, individual little pixels that light up, so to speak. And when I'm moving my hand across, what's happening is my hand's being illuminated right now. Let's say this blue pen right here. Right here. Well, it's black, sorry. Let me get the blue pen here. The tip of that blue pen. Right now, the screen is rendering all the colors to blend together to make blue. Right? And I think blue might be actually one of the actual primary colors within your screen there, and the processing unit of the way your phone works or your tablet. Let's use brown because brown's a combination. And green would be even better because green would be like a mixture of the blue and the yellow. But as I move this across the screen, what's happening is right now it's rendering all these, where is that? Where this is, all the lights on your screen right now where the brown is being rendered as brown. When I move the pen, those are now being rendered as this color, just kind of off brown tan color of the wall right now, which it's actually white, but the way the phone is and the lights I have on kind of make it look more brown, or kind of tannish color. Anyway, so these lights are on, like the girl's legs. Move the pen, these lights turn off, these lights turn on. These lights turn off, these lights turn on, right? So these are changing to a different color, and these are changing to a new color. So it's literally just a changing colors on your screen that give the illusion that I'm moving the pen. Now, let's say I'm actually really moving this pen, but what you're seeing is an illusion. You're seeing it. That's not really happening on the screen. There's no movement on the screen. It's a changing of colors. It's an illusion, but it looks real. So on a microscopic scale, when I actually move my hand back and forth, it's actually a changing of electronic states that is taking place. And this happens within the mind. The mind is seeing that because it's not really there like a video game. So in a video game, this is really cool. And this is the way the twin paradox works. If you're not familiar with the twin paradox, definitely go check this out. And then I think this will help you appreciate the twin paradox that much more. And I think it makes it make a lot more sense if reality works this way. Again, this isn't the way I want reality to work. It's just what the evidence has showed me the way it works. And I can go to all the evidence that I take a long, long time to show you how I came to this conclusion. So you have frames in video game. So if I program the video game, I don't program an explosion, let's say. Let's say I have a bomb in a video game like Grand Theft Auto 5, and there's a tank. You can take the tanks, you can shoot them, and they blow up. There's a certain amount of time it takes for that tank to blow up and finish blowing up and hit the ground before it stops. Let's say it takes exactly 3 seconds for our time, when the game is moving at 60 frames a second. So when the game is running smoothly at 60 frames a second, boom, it takes 3 seconds for it to blow up and all the stuff to hit the ground, and then it's over, right? For the sound and everything to be over. What happens when you put a bunch of those barrels? You ever done this? What happens when you put a bunch of those barrels in Grand Theft Auto 5 and you're trying to lag the game, and boom, and it takes forever for the explosion to finish because the game's lagging. So the reason why that is because when you program a video game, you don't program it. There's no time in the sense of time. There's changing of states. You program how many changes of states need to happen for it to be completed. So for the explosion, I don't program last for 3 seconds. I'm programming how many frames do I want this to last for. So if the game is moving at 60 frames a second, and I want, let's just say, the explosion to last exactly 2 seconds, then it would be, if the game is moving at 60 frames a second, and it takes 2 seconds, it'd be 180 frames, right? I think that's correct. 120 frames. Yeah, 120 frames. So 120 frames for the 2 seconds to happen. So I would program explosion takes 120 frames. Not takes 2 seconds. I program it takes 120 frames. So what happens then, if for whatever reason your PlayStation 4 or whatever game system you're on, computer, whatever, if it starts to dip below 60 frames a second, the explosion from your point of view takes longer than it's supposed to. It's programmed to take exactly 120 frames. Those 120 frames have to happen. It doesn't matter how long they have to happen, right? So once you shoot that thing and it blows up, if you cause enough lag, even to where it pauses, and takes forever for the next frame to happen, it could take an hour for that explosion to finish, from your point of view. But from the point of view of the video game, guess what happened? It took exactly 120 frames for the explosion to happen. It doesn't matter how long it took you to experience it. According to the video game, according to the programming language, nothing weird happened. It was only weird to you. You're like, hey, that was weird. Let's say you experience lag and it dips down to 30 frames a second, so it takes 4 seconds for the explosion to happen. Like, that was weird. That explosion seemed to take a lot longer than it usually does, because it used to happen in 2 seconds. The video game, nothing weird happened. It still took 120 frames for the explosion to take place. I'm driving this home for the twin paradox. So what causes, in my view, the twin paradox? If time is relative, like Einstein said, but not for the reasons that Einstein said. It's for the reasons that space-time is an illusion and that we consciously are moving through the slices of space-time. Right? So we are A theory and the universe is B theory. And we're moving through consciously through these slices of space-time. But sometimes our consciousness is interpreting it differently, moving at different speeds. We're processing the information at a different speed than somebody else. Therefore, we don't agree on times. And so, for example, in the twin paradox, if you're not familiar with it, in the twin paradox, you have the Earth. Let's go and zoom in on this real quick by just moving the camera forward. Zoom. All right, so we have the Earth. You have the twin on the Earth. He's like, yeah. And then and he's 20 years old, let's say. And you have the other twin. He goes up in a spacecraft. Anyway, so, right? That's a spacecraft. I can actually draw, by the way. I can actually draw pretty well. For those that don't know, for example, I'll go grab a sketch I did for a watercolor painting. So here's a sketch I did for a watercolor painting. This is Samantha Stone, comic book character that I designed, and probably gonna. I'm also a writer, for those that don't know. Looks like everything's still moving. Hopefully, I probably should stop that and start everything over. Oh, that's gonna be hard to redo that now. Hold on just a second. I'm gonna stop all this for a second. The other twin's inside the spaceship. If the spaceship goes around Earth over and over again, close to the speed of light, and it does this from this guy's point of view for 20 years. So 20 years later, the spaceship re-lands. Twin comes out. He's like, hey, how you doing? This guy is 40 years old now because 20 years has passed. This guy, literally, from both people's point of view, he looks in the mirror. He sees himself as, let's say, depending on how fast he's going, we'll say 25 years old. He looks at his twin and is like, oh my God, you look 40. What happened to you? He's like, well, 20 years have went by. He's like, well, yeah. 20 years went by for me too, so why do I look 25? And why do you look 40? That's the twin paradox. How can it be possible? How is it possible that he, inside the spaceship, experienced 20 years, and he on Earth experienced 20 years, yet clearly they're different ages? This has been proven. They've taken a atomic clock, put an atomic clock on Earth, put an atomic clock in a spaceship, flew the spaceship as fast as they could around and around the Earth. Then it came back a bunch of time later. Based on general relativity's equations, they calculated ahead of time what the difference between both clocks should be. Now it was within milliseconds, or I think even less than that. But with maybe I think it's faster a little bit. The difference was better than nanoseconds, but the difference was enough to where it could be calculable. And I can't remember exactly, look up the experiment to see what the exact time difference was, but atomic clocks are always synchronized. They don't change. They're the most accurate clocks. So and they did these types of experiments more than once. And when it landed, the clock on Earth and the clock on the spaceship did not match. This one was slower than this one. So in other words, this one aged less, so to speak, than this one. Now, why is that? According to the basic understanding of Einstein's relativity, how this twin paradox is explained is that basically everything, when it approaches the speed of light, slows down, becomes more static. Every molecule in your body, every molecule on the clock, every atom within the atomic clock. So the faster you go, the slower you go. Now, why? That's the question. Why? Why should that be? Just because light is some speed limit of the universe, the closer you go toward the speed of light, why should all the atoms slow down? Why is that? I think there's enough evidence to show that movement in itself in space is indeed an illusion, that it doesn't actually happen, that us moving is all in our head through static, through beat theory of time. Everything is static. I'm going to go through the shape of the universe a little bit, but I want to explain this process of time frame video game. So I went through how a video game works with the frame. Some of you have already put it together. Come on, focus. There we go. Some of you guys have already put this together, what I'm about to say right now, right? Your brain's already figured it out. You're like, oh yeah, I'm 2 steps ahead. I know exactly where he's about to go with this right now. For those of you who aren't, I'll go ahead and explain it real quick. So, the faster you go in a video game, what did I say happens? Frame lag, right? The more stuff that's happening on the screen at once, the more that has to be processed, the harder you push the PCU, right? The processor of your system, computer, PS4, whatever, the harder you push that CPU and the harder you push that RAM and everything, the harder you push that system, it can't process all those ones and zeros fast enough. And so what you experience is the lag inside the video game. So it still takes 120 frames for that explosion to happen, but from our point of view, since we're experiencing time differently than the video game, because the video game is saying 120 frames for an explosion, that's not how long it's taking for us, because the system's lagging, we're not. So we're not lagging, the computer system is, and so we're experiencing it going very, very slow, right? But from the video game's point of view, it doesn't matter. It'll happen at 120 frames. It's no different. So we are like a processing unit. We're like our own individual process. We're processing all this information coming in, right? So the two twins are two different processing units, both processing information coming in. The guy on the Earth isn't moving very fast through space and time compared to the guy that's in the rocket ship that's going super fast. Same thing with the atomic clocks, right? So the atomic clocks, though they're not processing units, right, they are things that seem to have movement. They have changing of states. And those changing of states take place within our minds, right, of this static universe. But still, when one goes fast, the way that it's all being like processed, the so-called movements being processed, it's going so fast it causes a lag within this three-dimensional static universe, right? So that lag, from the faster something goes, the more processing power is necessary for it to appear to move to us. Basically, the universe, since we're processing units and we're limited, we can only take so much speed, so much information, so much. The universe, if it has this apparent movement, that virtual movement has to be processed by us when we record it. So when we send a static object like a clock around the Earth really, really, really fast, all that processing is actually happening in all of our consciousnesses. And so when we go and record the data, this is similar to why the double slit experiment does what it does. It's not that our consciousness affects the experiment. The experiment would work the same way regardless whether or not but because we exist, it has to do what it does. If consciousness didn't exist, then the double slit experiment would never happen. because one, there'd never be no one there to put some sort of meter to read what slit the photon went through, therefore collapsing the wave function. If there wasn't consciousness, there'd be no one there to do that experiment. But even if there could be some way for that experiment to just happen by itself without consciousness, if say there was one where there wasn't a meter, one there was a meter, so one has the wave function collapsing, one doesn't, it wouldn't matter. The universe would still make that happen. It would still happen because of the Heisenberg's uncertainty principle. And that deals with, that's again a whole different topic, but just look up Heisenberg's uncertainty principle, and that's that you can't measure the momentum of something and its exact position and get them both accurate when you're dealing with small stuff on the microscopic scale. Because the smaller you get, the more you're getting closer to this Planck time here, the closer you get to this kind of like abstract movement of eternal information. So when you're trying to measure things on a small level, it's really hard to, the more you know about where they're at in space, you take a measurement, like that's where it was, right there. Okay, well, how fast was it going when it was there? Don't know. The more you know about exactly where it was, the less you know about how much momentum it had. The more you know about how much momentum it had, the less you can know about exactly where it was. And it's also deals with spins, all kinds of stuff. It's really cool. And that's something that we have not been able to violate. The Heisenberg's uncertainty principle. So that's actually why the double slit experiment works the way it does. Because if it didn't, you would violate Heisenberg's uncertainty principle. Because you already know the momentum coming out when you shoot the particle, and you can measure that with pretty great accuracy. And so if you can also measure its position, then it has to delete the momentum, and therefore that's why the waveform collapses. When the waveform collapses and acts totally differently, and we get a different pattern on the wall, we can no longer trace back the momentum. It's like, well, it should have this momentum, but now the waveform is different. So now we can't know its exact momentum once we know where it was at in space. Its momentum is, it's almost like it deletes its momentum. It doesn't delete it, but it gets fuzzy. It gets harder to see. Because of the changing, that's why it actually changes states, because of that reason. So with the clock, the static clock, all that is being processed in all of our brains, whether we know it or not. Whether we're aware of it or not, it's all being processed. Every planet moving, all this stuff is being processed within our consciousness at all times. Because why? Because we are processing units, and we're consciously moving through these static frames. And because we're constantly moving through these static frames all together, we're processing all that so-called movement when nothing's actually moving. So even the spaceship going around the Earth with the atomic clock in it, that never happens. It never actually moves. It's always existed in all those states. Everything that can happen has already happened. But we as conscious entities see it as now. And we're processing it as now. And we have a memory of things that happened, an idea of the future to come, expectations. And so what happens is it goes around and around the Earth, but it's going so fast that it causes more lag in our brain compared to the clock on the Earth, which is going slower within our conscious processing unit. And so when we bring it back, the atomic clock appears to have aged less because all of its molecules and everything slow down, meaning because every molecule moving through space-time is not really moving, but we think it's moving, and it's being processed as if it's moving. It's the changing of states, the frames, right? So how many frames it has to go through is a lot more than the amount of frames the clock on the Earth has to go through. And because of that difference in frames, the faster this one is supposed to be going, the slower it lags. It doesn't lag, but from our point of view, it's lagging. So we would say is all the atoms, what Einstein would say is all the atoms on the clock that's on the spaceship, they all slow down, therefore the entire clock moves slower. The atomic clock that's on the Earth, it moves at the same speed as it always has. It doesn't slow down because it hasn't gone faster. The one that's being propelled faster on the Earth and the one that's faster in the spaceship around the Earth and the one that's on the Earth. So the one that's on the Earth moves at the same speed. The one that's going faster moves a little bit slower because everything slows down. Every molecule, everything. The faster something goes, according to Einstein, everything slows down. That holds to be true. Now, my theory, what happens is, because I would have to explain how this all works, right? If you have a whole model of reality and you can't explain something like that, then it doesn't work. And you have to throw it away. So how this works is, and if my model's correct, it has to explain this. How this works is that when that clock is moving around, it's going faster, so it's taking more processed information. It's causing more lag. Therefore, it takes a certain amount of frame rates in our brain for that event to take place than it does for the clock on the Earth. And so that makes it appear to us, the illusion, that the atoms and everything have slowed down in the clock. Therefore, we see a difference in time when it comes back. So with the twin paradox, what happens is, we all would sit here, if we can actually do this experiment. We're on the Earth, we have a twin, and we make him fly around the Earth a bunch of times. Let's say we can't get close to the speed of light because it takes too much energy, but we get going super, super fast to where we can actually see a difference in our age. Let's say we start when we put him on the spaceship when we're both 5 years old. So when he comes back, I am, let's say, 70 years old. He comes back, he appears to me to not be 70. We don't look the same at all. He looks like he's, let's say, 60 or 55 or something like that. It depends on how fast we can actually get him going. The reason why that happens, according to Einstein, is because everything on the spaceship slows down. Every atom, everything, right? So every atom in his body slows down. Therefore, he ages less slow. But why is it that he experiences the exact same amount of time as I did? Let's say he goes for, okay, we start when we're 10. He comes back when I'm 70. So that's 60 years. When he comes back and we both talk, we both say we experienced 60 years. Like, hey, how long? According to my clock, right? I have a clock. He has a clock on his spaceship. I have a clock down here. And according to our clocks, we both experienced 60 years. Yet he looks younger than I do, a lot younger. Why is that? How is it that he didn't age? He physically didn't age. Yet we both experienced the same amount of time. Because time for him all slowed down. So his clock and everything slowed down. Everything has slowed down for him. So he still experiences the same amount of time. So you're not really like traveling in the future. You're not like extending your life, right? So some people say, oh, that's cool. I want to get a spaceship and go as fast as I can so I can live longer. You don't really live longer. You still experience time the same. That's why time is truly relative. Why is that? Because he is going so fast that his processing is lagging. So he's experiencing time slower, right? So to speak. He is processing all this information at a different way than I'm processing information on the Earth. And so when he returns, to me, he looks younger. To him, I look older, which is a true thing that truly actually would happen, according to Einstein. And according to the experiments that have been done, the clocks and stuff, that's what happens. We would see each other as these different ages, but we had both experienced 60 years. So the reason why we both experienced 60 years yet look different ages is because it took the same amount of frames, so to speak, from my point of view, to watch him go. Let's say he went around the Earth 3,000 times, just some random number. I think it'd be a lot more than that if he was going that fast, but let's say 3,000 times. That's how many times he went around the Earth. That's true for both of us, right? Because from my point of view, I watch and I calculate it. I'm like, that's once, twice, and 3,000 times. From his point of view, he looks at the Earth. He's like, once, twice, 3 times. We both agree. You went around the Earth 3,000 times. But he's going so fast that his whole entire processing unit is slowing down, experiencing time differently, right? So he experiences time differently, even though he's going super, super fast. And I experience time differently than what he experiences at. So we're going to agree on everything. It all has to do with frame lag. So the better way to kind of look at it is like the universe has frame lag in it, so to speak. Even though it's static, so that's not really, but it's kind of an easy way to kind of comprehend it, is that as he's going, he's experiencing frame lag, right? So it still takes the exact same amount of frames for this event to happen, right? However many frames it takes to go around the Earth 3,000 times, That has to happen. Those frames have to happen. But if there's a lag between the frames from my point of view and his point of view, then he's going to age less than me, because he has actually, the amount of frames that have actually happened from his age are different than the amount of frames that happen from my point of view, to my body, so to speak. So there's a frame discrepancy. So his frames hasn't finished carrying out as far as his lifespan goes, because there's a frame to your lifespan. That is, you have a certain lifespan that you can live to, right? And there's genes and everything in you, and all those genes are functioning. You have what's called a death gene, and that death gene pretty much tells you when you're going to die. And in order for you got, anyway, that's a whole different topic, but you can look this up. There's an actual thing that we discovered called the death gene. There's also the youth gene called the Goldilocks gene. That's like the layman's term. That keeps you youthful. And we've learned how to bypass this in worms to make worms be youthful their entire life, to where they never get old. But they do die. But we've been able to expand their life. Last I checked was by like 5 years. And as we were able to make worms live 5 times longer than they normally live. And I think it's higher than that now. I can't remember. I'd have to look up the experiments to see if we've moved on to higher life forms and worms. But basically, so you can kind of see how that would work. So in the video game, it's kind of like the video game analogy. So it's as if he's playing the video game. He knows, he looks up in the spaceship, he knows what should happen, how many, like this is how long it should take for him to come back. And that happens. But because based on the speed and everything like that, because there's not lag in the actual spaceship itself, as far as how fast, like the speed, he can calculate and go, okay, this is when he'll be back. He'll be back in 60 years. And this is how many times he'll go around the Earth in 60 years. All that can be calculated. And he can even calculate for the exact amount of age discrepancy there'll be when he gets back, because we know that based on Einstein's relativity. Prior to Einstein's relativity, we would be just blown away. We'd be like, what? If we didn't have Einstein's relativity and we did this experiment with twins, we would be blown away when the twin came back looking younger. We'd be like, what the hell happened? Not only that, but we'd be blown away by the fact his clock is way behind, years behind, right? His clock will agree with his age. So let's say his clock not just told what time it was, but also told what year it was, what month it was one of those clocks, right? His clock would be the same age he is in relativeness behind. So if he was, let's say, 20 years behind, his clock, his watch, would also be 20 years behind the guy, the twin on the Earth. So the twin on the Earth would be like, hey, my clock says this is the date, your time. His clock would be different. They'd actually disagree on what year, what date it was. And so the twins would be arguing, no, it's actually, or it's actually 2030, and the guy being, no, it's actually 2010 still. What are you talking about? Because he has gone so fast that lag happened, that there's frame rate, everything went slower for him. And so when he comes back, his clock, everything went slower for him because of that frame lag. Hopefully that makes sense. Okay, let's get into the shape of the universe, because that's kind of cool. That is, how is it we make choices? And I know this video is super, super, super long, but this can be so much longer. My philosophy is so in depth, but this is more than philosophy. This particular part of my philosophy is something that I'm working to make an actual scientific theory. This part right here, how time works, how the universe works, how we are A theory consciousness beings, and how the universe is a B theory static type universe. That, and then I'll go into the shape of the universe. All that is a scientific model that I need to work with some physicists, or at least a physicist, to do all the math, everything, and see if it works mathematically, to make a mathematical model out of the concept. If the mathematical model works, it makes accurate predictions, all that kind of stuff, and we can falsify it and then make predictions with those things, and then see that those predictions are true, then it will become a scientific. Well, it'll start as a hypothesis, then it'll become a scientific theory if we can prove those things true, and that'll be crazy. And what would be really crazy is if the math actually predicts the weight of the Higgs boson that we found, because remember, it's not the weight, well, I guess mass, whatever. It's not what the standard model predicted, and it's not what string theory predicted. And if I ever get around to be able to do this, to find the time and everything to do this, and work with a physicist and get all this done, it would be crazy if it makes a prediction that based on the mathematical model, it can only make one prediction. And if that prediction is that that's the mass it should have, the mass that we actually found, that'd be crazy. Some people might say, "Oh, you made the math match that," but they would know that wouldn't be the case. So they would see it's a full mathematical thing that makes many other predictions, and that all that has to be true internally within the theory. And that would just be one thing that it predicted. And it'd be too hard to try to write a theory to match just that one number and then also match everything else. So, all right, that's that. Okay, so now let's get on to the shape of the universe and why you have free will, if you want to call it that, why you make choices and you're not just like a robot that doesn't make choices. That fate's not true. There's not just a single line you travel down. There's actually multiple branches, and that's where the whole entire universe is shaped like a tree. I don't need that much paper to draw this part, and then I'm gonna go into how. Actually, I don't think as many people care about that as they care about life after death. Okay, so how does this model of the universe make it possible for life to exist after death? Most of you guys probably figured out. It's pretty easy, right? Well, I shouldn't say that because it might not be easy for everybody. But for some people, you figured it out already. If this is all true, right, then there's no reason that you're just a processing thing. That's all you are. That has memory and processes information. That's the present, and is capable of thinking about the future. You're capable of processing information and thinking about it in different ways. You have consciousness, which makes you be able to think about things, calculate things, and actually see the future, so to speak, because it's already there. So of course you can calculate it. Because of that is true for us, then if it can create, so to speak, it's not creating us. We are just experiencing time because we're moving through these slices of space. But if it can make this processing unit, why can't it make another processing unit? That is why, if this is all an illusion, all this solidity is actually an illusion, and this isn't actually who we actually are is information being processed. Like fundamentally, that's all everything is. It's just information being processed. If that's true, then there's no reason, as long as it's logically possible for it to make it, it could make another form that has the ability to think and remember, and maybe different properties that interfaces with this brain and this process unit. So in the same way that you can hook up two computers together to communicate and make a supercomputer out of it, or take a network of computers and make a supercomputer that processes things faster, then you can have another part of us that makes consciousness possible. And so it's kind of like, if the world is like a video game, because this means the world is like a video game, right? Where time as we experience it is actually just changing of states, therefore it's like frames, like a video game. So many frames, so many changes of states for something to happen. So for us to get from point A to B, we never moved anywhere. So many states have changed. And as far as we know, the whole entire universe could have lagged for 1 billion years and we would never know the difference, right? Because everything lagged. We lagged, everything lagged. We just paused. And you would not know that. Matter of fact, right now, this is a really cool, trippy mind experiment. Right now, let's say, boom, time froze. And during that moment, that time froze, none of us knew it, but it froze for 1 million years. How would we ever know the difference? We wouldn't. If everything, the entire universe froze simultaneously, boom, for 1 million years, or for 1 million frames, right? Because in my view, it all works by like states. But we'll say from our point of view, for 1 million years, time froze and then unfroze. How would we know the difference? Because we wouldn't age. If everything completely froze and got static, we would not age. Nothing would age. And then if it unfroze, everything would be like exactly where it was before, and we would never know the difference. Think about that for a moment. That's a fact. That's a logical fact. That if everything in the universe were to suddenly freeze right now for 1 billion years from our point of view, and then unfreeze, we would never know what happened. We'd have no way to calculate. We'd have no way to figure out that the universe actually froze. It'd be impossible to figure out. So for all we know, it freezes all the time in order to catch up, in order to process all this stuff, and then unfreezes, and then everything goes back again. Or we experience this big universal kind of state of consciousness lag where everything is lagging at the same time, and then it unlags. And since everything is unified lag, it's not relative. So there's no way to calculate the difference, and so we'd never know. Anyway, very just kind of interesting, right? But anyway, think of the World of Warcraft. I never got into it very much. The highest I ever got was level 13 or something like that. I thought the story was kind of cool, but just not my kind of game, I guess. I don't like long games. But some of the quests are pretty cool, but I can see it getting repetitive really fast. And I love The Witcher 3 though. But anyway, so one thing I do remember about World of Warcraft is when you died, you didn't just restart. You became a ghost. And as a ghost, you can move through walls and stuff, if I remember correctly. Now, if I don't remember correctly, just don't beat me up if you're a World of Warcraft fan. Instead, we'll just pretend I'm correct. Let's say if I'm incorrect about World of Warcraft working that way, because it's been a long time since I played it, let's say there is a video game that works that way. And how the video game works is that when you're alive and running around, the program says you can't walk through trees, right? The only reason why I can't walk through this is because the programming says I can't, right? Because the programming says that my electrons and these electrons bounce off each other. They repel each other, which makes it where I can't walk through the wall. But if the programming were different down here, which programs this to be different, then I can just fall right through this wall. Boom, because there's no electromagnetism stopping me from going through the wall. So suppose there's a video game that works that way, to where it programs the characters when they're alive to where they can't go through what's considered physical objects like trees and walls and things like that. Remember old games? You get stuck on like something stupid that you should be able to walk through, like a box, a cardboard box, and you walk in and you're stuck, and it's glued to the ground permanently, and it's like so strong you can't just walk through it. Nowadays we have a lot of physics, so in the game, so you can actually kick the cardboard box, so to speak, and move it around and everything. But anyway, so that was a programming thing. The program said you can't go through that box, so you can't. It doesn't matter whether it's logical or not. You can't go through it. That's what the game said. So in this game, when you're alive, you're playing the game. The character can't walk through what's considered solid objects because the programming says it's a solid object and says when these two things collide, they don't go through each other. But when you die, you become a ghost, and you're kind of like transparent in the video game. So you look like a transparent character. You look the same, but you're transparent. So that's how you know you're a ghost. You're like this blue transparent character. You don't have no color to you anymore. It's not just transparent. You're monochromatic blue, and you're transparent. But now the game tells you when you're in that state, when you're dead, when you're in that body, when you're in the ghost body, the programming is different in the game. The programming says you can walk through so-called physical objects. You can walk through walls and trees and stuff. So now you can just walk through everything really fast, get back to your dead body, and then bring it back to life, and then there you go. But you have to go and find your body because your ghost pops up somewhere randomly on the map. Now you got to run in a straight line. You'll see a dot on the little GPS thing. You'll see a dot there, and you have to run straight to it. And once you get back to your body, if you get to it in time, your body comes back to life. Let's say there's a game. You can program that very easily. So if reality works like a program, it can easily program that to be that way. It can program it to be to where you have some sort of ghost body that is conscious, and it has different properties applied to it because the programming tells it has different properties. So instead of telling it that, hey, you have electrons and electromagnetism, that's why you can't go through the wall, it tells it you don't have electrons. Or not electrons, I mean electromagnetism. You don't have atoms. You're not made of atoms. You're made of something different, or some different kind of particles altogether. But it's still all natural. Natural in the sense that it's all made from this logical information. I think it can be illogical because this is a logical system, and everything that comes from it must adhere to that logical system. And so it tells you that you have different properties, and that when you die, your ghost has consciousness. Maybe that consciousness works differently. Maybe memory works differently. Maybe the way it processes information works differently. But one thing that it does differently is it tells it that you're made of a different substance, and the substance that you're made of can walk through walls. It's not subject to electromagnetism, so it can go right through things that have electromagnetism. That is, It doesn't have atoms, so it's not subject to electromagnetism, so it can just walk right through a wall, through a tree. It can float right through the ground. It can float up or down, you know. And that's one thing that's weird, right? Anyone ever thought about that? Like when people talk about ghosts and stuff, the ghosts are like either like floating or walking on the earth. They don't fall through the ground, but they can go through walls. And but anyway, the game can say that too. It can, you know, I can program it to be like, well, you can't go down through the ground, but you can walk through walls and stuff. Which, you know, logically doesn't make sense when you think about it, but it can program it that way, and that's logical because it's not breaking some logical error. But I have to give some reason for why the ground is different. You know, like why the ground is turned on, everything else is turned off. But it's better just to think of it as the ghost consciously chooses to want to stay floating above the ground because that's what it's always done when it was alive. And then if it wants to, it can float right to the earth and just go right to the center of the earth and out the other side and be in Japan and keep on going out in space and go through the stars and the suns, you know, and just float where it wants to go because it's not bound by the electromagnetism. Anyway, so it can do that, right? So that's how life can exist after death within this model. And in fact, within any model like the holographic principle or any informational theory like It from Bit by John Wheeler, the physicist that's been dead for a while now, any digital physics, any simulation theory, any of these kinds of theories that deal with the fundamentals being information, then it's possible for there to be life after death. So in my view, you have a ghost body, and that ghost body is made of natural substances, and those natural substances follow different rules, which is dictated by the eternal information. And those rules make it to where you can do things like walk through walls and stuff. And from my experiences and what I understand, this is where you get into my philosophy and totally outside of science right now, at least outside of science as we know it for right now. This is more metaphysics. The ghost has parameters that allow it to walk through walls. It's not subject to electromagnetism because it's not made of particles that we're made of that are subject to that would push against that. Like neutrinos, for example. Neutrinos is a particle, or rather, neutrinos are particles that we have found that could go right through the earth. They're going through us all the time, actually. They're going through the earth, the sun, they're going through our heads. Neutrinos are constantly going everywhere through everything. And so it was really hard to find them. We had to go deep under the ground, we had to make a big lead building, and it took a lot of money, information, and instrumentation rather, to finally be able to find that little speck that wasn't, you know, the lead was to block out any other radiation stuff from outside. We needed to make sure that there's no contamination coming from outside sources. We need to know that what we saw was actually a neutrino, and that it had the same properties of neutrino. Sorry about that. My phone had a little thing in front of it, kind of bothering me, that popped up. Okay, so that being said, that's how the kind of like how the ghost body works, and it follows different rules. Its memory follows different rules as well. Oftentimes, it will not be able to remember what it was when it was alive, and it has to try to remember that. And that's just one of those things that it's programmed to forget, to help it stay sane, because you kind of go crazy a little bit when you realize you're dead, and then you're like, oh, I want to talk to my loved ones, but you can't. Maybe if you're really, really good at it, maybe through dreams and stuff. But anyway, so there's, you know, and all of that's logical and possible within this model. But things that are illogical are not possible. So it's not possible for something to be eternally in some state and then change states, because the eternal state must always be the same. So it'd be impossible to say that this pen was eternally closed, right? This is open, this is closed, caps on. So I'm gonna call that, this state is closed, this state is open. If I said it was eternally in this state, in the closed state, it has to always be in this state, right? Because the second I do this, it's not eternally in that state anymore. It's changed states. So I can't say it was eternally in a closed state, right? It was in there. You know, let's say one way to look at this would be like you draw a line on a piece of paper, and you say this is, or rather, we draw a line on a piece of paper like this, and we go that way's forever, right? So I don't want to see that. So we do like this right here. We have a line on a piece of paper going this way, and that's going back forever. And this is the point right now where it's now in an open state. So prior to this point backwards, the pin was in a closed state. So we can say, well, hey, that was eternal, right? Because that goes on forever and ever and ever and ever backwards. And once it reaches this state, it opened up. The problem is, if it's in a true eternal state, it's without time, or it's within eternal time. Eternal time goes both ways. So you can't put a dot anywhere on an eternal line because it's arbitrary. It makes no sense. To put a dot there is no different than putting a dot there because the line is infinite. So no matter where I put one single dot on that line, it doesn't mean anything. It's the same. That's a little more deeper for some people, but it's logically sound. You can check with the professor. That is, when you have an infinite line, when you put a dot somewhere on there, no matter where you put that dot, it means nothing because there's nothing else for it to relate to. There's infinite direction. There's infiniteness in both directions. So no matter where you move it, there's always infiniteness in both directions. So it makes no sense to say it went for an infinite amount of time and then opened up. It'd be arbitrary, totally random, and would make very little sense. But anyway, so you can't have contradiction like that happening. You can't have things like violating their very nature. So if the nature of something were eternal, it couldn't stop existing because the nature of being eternal means that you've always been. So you can't just stop it. So if the universe is in a B-theory state, a B-theory state of time state, that's kind of hard to say. Basically, if it's eternal, then it can never stop being. It has to always be there forever and ever. It can never stop being there. It can never just vanish. So this projection has to always be there and always has been. So that ghost body then can have different rules and things like that. And there's nothing to say that's the only thing that's related. Maybe the ghost is some in-between thing. Now this gets into my philosophy, where you have this ghost body that interfaces with the body, but it's a go-between. It's a mechanism for the true self, which I call Nam, which is where I get Namicism from. I told you I would tell you that. And so now you know where I get that, why I call my philosophy Namicism. It comes from the word Nam, which comes from a Hindi Nam, but it's longer. It's a longer phrase, like Namaste. And you have I forget the other one right now. And Namaste is basically me and you blesses the divine in me blesses the divine in you. But what I liked about the idea of Nam, can't remember the phrase right now for some reason. But I was studying all this stuff a long time ago, and then I was like, I like that word. That's kind of cool because by itself it can mean like self, trueness. So the true self, the Nam, the truth. It means the truth literally. Nam in this. I think it's Nam, Sat, something, and I can't remember the full phrase right now, but it means truth. And I took the idea, I like the word Nam, it sounded cool, and so I just took that to mean truth, the true self. And so that's what I use when I say your Nam, I mean your true self. But I don't mean as soul or spirit because it's natural. Remember, none of this is spiritual. What one can say, but isn't that a spiritual thing? The ghost you just described, isn't that a spirit? No, it's not, because no one defines spirit. It's a natural thing. So that's the difference, is it's not supernatural. The ghost isn't supernatural. The ghost isn't unnatural. It's still created or made to exist by the same eternal logical system, right? Everything is made from that, so to speak. Again, made is kind of a weird word to use because everything's always been. But so that ghost is a natural form, just like a neutrino is a natural form. It follows logical rules and systems, and it has to follow those rules, and it can't break them. And one could say, well, a spirit has lots of rules and stuff too. Well, that's fine, but it's not a spirit because it's not immortal. It can die. It has a form. Any form can be destroyed. That's the natural rule. That's the natural law of the universe. Any form can be destroyed. Consciousness, so forth. And then, so what the ghost is an in-between between yourself and your Nam. And your Nam is your true self, and it evolves. Now, that's a whole other video. If you want to get into that, the evolution of yourself, of Nam, and how you evolve into the human type form, to where you can actually interface with the human form, and how that works, and what the non-verse is, which is part of the universe, but it's different than here. For example, in non-verse, a black hole looks like a fountain of light, whereas here it looks like a black hole sucking light in. It's not like the opposite side of the universe either. I know that kind of would make that analogy would kind of make it seem that way, but it's not. If you guys are curious about true self, Nam, and things like that, let me know in the description below, and I'll tell you all about that. I can make a whole other video. I probably want to do it anyway. I kind of want this all recorded. I'm 39 now. Anything can happen. I can just die, get in a car accident or whatever. The older you get, the chance of death get greater and greater. So I feel like I should put all my. I don't have time to write all this stuff down. So I feel like I should put all it out there for the public anyway, and put all my philosophy out there, so that way, just in case something happens into me, whatever it is, hit by a car or something, then it's all out there already. All right, now I'll leave with this, and that is the shape, hopefully I can do this fast enough, of the universe, and why you have free will or free choices, how it is you make choices. So the shape of the universe is not like a football, like we drew up here. It's not like a flat, straight line. Instead, it's like a tree. It starts off with the trunk, and then it branches off. And then those branches branch off. And then those branches branch off. And then, just depending on the possibilities, whatever's possible for each of those branches are the different possible things that you can do. Very much like a tree branch. So it kind of looks like a tree, right? So when you begin your birth in this life, you start, because I believe in a form of reincarnation, and that reincarnation is also naturalism. It's a natural form of reincarnation, but you truly do reincarnate from different body. But the way it happens is all defined by natural laws and rules. It's not something that you choose. You can't choose it. You can't control it. I hate that part of reality. That's like my worst part of reality I hate. I also hate the part of reality that all forms can be destroyed, including yourself. I hate the idea that I can be destroyed. That part of my belief system really bugs me, but I have to go with what I know by experience and evidence. So as you're going down and you come across a possibility, now there'll be more than just two possibilities, but let's say there's just two branches you can take, two possibilities that you can take. Depending what branch you choose to go down, then that's the new possibilities that will be presented to you. Now let's say you're presented with a bunch of possibilities here, and you can choose to go down, once you reach this point, you can choose to go down any one of these possibilities. And that is, you can choose to make any of those choices. When you make one of those choices, it gives you a whole new branch of choices to make. Some of those choices run very parallel to each other, like this one here comes off, and it runs very parallel to all this, towards almost all the exact same choices are available to you, but they're not exactly the same. So right now, the fact that I chose to record this video propelled me down an entirely different path than if I didn't record it. But it might be so close to another, like, okay, let's say this is the path. Let's use these two pens. Let's say this is the path where I chose to not create this video. This is the path where I chose to create this video. They can be very parallel to each other, to where almost every other option I have presented to me will be almost exactly the same. But at some point, there might be a couple little differences. They kind of stray off. For example, if I had never made this video, maybe a physicist never reaches out to me and says, hey, I'd like to work with you on that theory. It's really cool. But because I made this video, maybe a physicist contacts me and says, hey, I want to work on that video. That's a whole new branch that I never would have been presented, a whole new choice that I never would have been presented if I had chosen to never make this video, right? If I would have chosen to make this video years ago, I might have had a different physicist call me, and that presents a whole new branch of things, and maybe he would have not been able to make it into a proper mathematical working model, therefore make it into something that can be disproven. In other words, it never would have became a physical model within physics. Never something that could be accepted. But because I chose now to make it, maybe the right physicist gets a hold of me, and then we work together, and we come together, and we make a model that actually works, and we win some Nobel Prize. I'm not saying that's going to happen. I don't have this big of a head. I'm just saying that could be one possibility. I'm just trying to use an example. It could be the fact that I chose to make this video. For some odd reason, I can't think of how this happened, that I am presented with a different choice to where I get in a car accident or something. Like, I'm not sure exactly why that would happen, but maybe if I didn't make this video, I would have went for a drive and got in a car accident. But because I chose to be here for all this time and make this video, by the time I go out and drive, that accident already happened and I avoided it. And I see it, I'm like, oh wow, if I would have went out 2 hours ago, that could have been me right there. Those choices happen all the time, every day. Matter of fact, I have a story real quickly that happened to me. I was driving, and I can't remember why I stopped for 5 minutes, but I stopped for 5 minutes and I had to do something. I'm like, hold on, give me 5 more minutes. Me and my girlfriend at the time were trying to go somewhere, and I'm keeping it general. I knew exactly where we're going, exact town, everything. I'm just keeping that general information for now. And so we're on our way there to that town, but I was like, hold on a second, I gotta do something. And I took about 5 minutes to do it. I didn't have to do it. It wasn't something I had to do. I just wanted to. So I went and did that. We got in the car. We were driving, and literally right above us, it looked like it happened like 5 minutes before we got there. These two cars like smashed into each other, and it was crazy. I'm like, wow, that was about like 5 minutes ago. It looks like, I'm like, what happened? What would have happened if I chose not to do that? That could have been us. We could have been right there in that car, smashed. They weren't dead though, so that's a good thing. But their car was all fucked up, and they could have had whiplash, who knows, or what kind of problems they had. But that can happen anytime. It's weird, right? When you think about it, like just the weird choice, like one little choice. Sitting here and watching the rest of this video can save your life. Like literally could. You stay here and you watch the rest of this video, and then you go driving or go somewhere, and then you see a horrible like shooting, a gang shooting or something like that. Like, oh damn, if I would have been there 5 minutes earlier, I would have been one of those people who got shot. But because I stayed and watched Neil ramble on for a little bit longer, then I didn't get shot. I mean, just saying. Now, I'm not saying to watch the video because of that. I'm just saying as an example. That's a horrible example. But it's just a possibility. So there's all these possible chances. So anyway, that's how we make choices. So the true shape of the universe is more like a tree than it is a football. So imagine this football branches off, and there's all these different possibilities. So anything that's possible is only possible. Only things that are possible. So the branch of possibilities are only things that are possible based on the logical system. If the logical system cannot make it possible, then it's not possible, right? I can't fly through the ceiling right now. It's just not possible. The universe doesn't allow me to do that. The programming says that my body can't do that. So I don't do it. I just tried, but it didn't work. Now some people believe you actually can do that. They really do think they can just fly through the ceiling. I'll pay you $50,000 right now. You can come and demonstrate that for me. That'd be awesome. But it doesn't mean that we can't necessarily. It just right now, no one can. No one has the ability to defy gravity like that. Anyway, so that being the shape of the universe, anything that's possible within that's what makes that branching tree for you. So the moment you're born, not the moment you're born. If you want to think about from your point of view, from the moment you're born, the tree already exists of all the possible things you can do, depending on where you. But so this is an infinite tree, so to speak. Now, before you're born, this already existed. It doesn't exist in the universe, kind of like as more of an actuality until you're born, so to speak, because that's dumb. I should stop saying that, so to speak. But this eternally existed within the universe anyway, always. And this is just one life. You die here, let's say. That's the path you chose to do. You died there. Go to Ghost World. There's all these different paths, branching. And then the ghost dies here, and then you go to numbers, all these different paths, and then you reincarnate and you start over again. A whole new branching path happens, right? So throughout your entire existence, you have many different trees that you're presented. And depending on what choices you make, so that's where choices is real. So for those that are deterministic, they might say, well, you're predetermined to go down that path or that path. You're not actually making a choice what path you're going down. You're presented with these choices. We can do it right now, even if I'm incorrect about the model of the universe. We know that we're presented with paths all the time, with choices all the time. That's a choice that I'm presented with because I have this in my hand. If I didn't have this in my hand, that would not be a choice to make, to take the cap off. But because it's in my hand, that was a choice that I can make. And it's something I always ask determinists, those that are absolute deterministic people. They say, well, everything is all deterministic because everything moves. But if B theory of time is correct, right, and everything has always been, then they might say, well, the choice, they don't even know how to describe the choice you can make. As a matter of fact, I don't know anyone else that I've ever listened to that subscribes to the B theory of time of the universe that's being able to explain why is it that we see time as a theory of time? How is it that we see a past, present, and future when there is no past, present, or future? It doesn't exist. And my theory, it explains it. And hopefully it made sense. If it didn't make sense, feel free to ask me questions. I'm a very, very busy person. But if I get enough people asking questions, I may make a follow-up video trying to explain it more clearly of how we're processing units and how we're flowing consciously through space-time, therefore giving the illusion of time passing and giving the illusion of movement, and then having the memory gives us the illusion that there is a past, and then having foresight and consciousness gives us the illusion that there is a future. But I guess in a way there is a past, present, future, since it's always been there, And as your possibility, it's always been there. Like informationally, it's always existed that you have all these possibilities. And informationally, you've done every one of them. Right? So from an informational point of view, from the eternal information point of view, you've made every single one of these choices. But you as a processing unit only make one of those choices. We know that's true. So if it's true that we're presented with choices, which we are, this is the choice I'm presented with because I have this pen. If I'm presented with that choice, this is to those that are deterministic and say that we don't really make choices, that choice is an illusion. If I'm presented with that choice, and it's already predetermined whether or not I take this off or not, that's two different choices, right? Two different branches. It's already determined whether or not I'll be here or be here. I'll either leave the cap on or I'll take the cap off. If it's already predetermined that I'll do one or the other, but all the physics shows that everything that can happen, that there's that all the possibilities exist, then I've already made both choices. And if I already made both choices, then you would say, well, that's kind of like, is that deterministic? If I've already made both choices. But me, right now, from my point of view, I'm only making one choice. How is that an illusion? How does that explain exactly what causes that illusion? I know what some people say is they're going to say, well, because the brain understands the past, present, future, but that doesn't matter. That's all what I just said. Everything I just said, that all movement, everything is all an illusion. Space, time, all that's an illusion, because we are thinking things, because we have a memory that does the past, because we process information in present time, because we can see foresight and think about the future, right? So that gives us this idea there's a past, present, and future. And there is, like I said, in a way, because it's always been there, but we are choosing to flow through those things. So if I'm correct, you can see how determinism doesn't hold true. If I'm correct about how the universe works, and this tree of possibilities have always been there, and according to information, I've already done all of them. But me as an individual, as a thinking thing, I'm choosing right now exactly which path to go down. And there's only one choice I make. What would in my model, what would determine what path I go down? Me, because I determine everything. We all do. And one question I'll leave you with is this: if my model is correct, if I make a certain choice, let's say me and my fiance are walking down the street and come to a path, and I'm like, okay, I'm gonna go right, she's like, I'm gonna go left. We go different ways. Does she disappear from my timeline? Is she gone? Does she vanish because we took different paths? No. Those paths are still interlinked. That the space-time is still linked together, right? We just walked down different paths. We flowed through space-time differently, but we're still in the same space-time, right? We haven't jumped to different. There's not like different dimensions, you know. When you so I just want to explain that I don't believe in multiverse. I don't believe that there's another universe right in front of my fucking face. Instead, I believe there are multiple universes out there. That's a whole different topic though. But those many universes out there isn't like the multiverse universe theory. They're not multiple dimensions where you are the president and stuff like that. No, it's not like that. Like informationally, if it's possible for you to be the president, informationally, it's possible for you to be the president. So if it's possible for you to ever become president, then if you make the right choices, you can get there. But you don't exist as a president right now. You don't exist as different things. That's multiverse theory. I don't believe that. Rather, instead, my model shows that you only exist in the now, and that's all. And everything is processing through you. All the slices of space-time are processing through you. All right, so that's been a super, super long video, but hey, I guess I had to make it super long because it took so freaking long to make it. And that's kind of why I didn't want to make it, because I'm like, who's going to watch all this? It's so long. I kind of more did it for me, because I just want it there. It's like a permanent record of my beliefs, so that if some physicist ever does come up with a theory like this and tries to take credit for it, I can go, look, I already had that theory. All you did was put math to it, which is something I already want to do anyway. I don't want to take the time to learn all the complex math. I can do it, but I don't want to take the time to learn all the complex math to make it into a mathematical model, then make it into a scientific theory, and then hopefully with enough evidence and experiments make it into an actual scientific theory, or scientific hypothesis and scientific theory. But maybe there'll be a physicist out there, and if they're already out there that want to help me turn this into that, I can explain all the more details. Like you run into a problem mathematically, I can explain the concepts to you that you can go, oh, okay, that makes sense. Let's work out the physics differently. Like you're taking the wrong directions with the physics, and I'm like, no, that's not the right concept. Go with this concept, and then that will help you do the physics better. But anyway, that is something I want to do, and I want to work with someone in the future with on. And I do, if everything goes away, everything's planned right now, and my money keeps increasing like it's been doing, then I'll have the money to afford to hire someone to help me on that. So, but you know, maybe someone will just want to do it just to do it, just because like they're so fascinated with the idea that they're like, hey, do I have permission to work on this mathematically, to work on this with physics, to try to make this into a theory? I'm like, yeah, sure, as long as I also get credit for coming up with all the concepts and work with me on the concepts. If you get stuck, talk to me. I understand the physics, the concepts of physics, put it in a conceptual form, and I can help you work it out to where it comes into a model that actually works mathematically. All right, so every guy, I'm getting tired. Everyone, thanks for watching. This has been a long time recording, so hope you enjoyed it. If you did, do me a favor, hit the smash like button. If you want to subscribe, you can. I do a lot of different stuff on this channel. The two main things. The main thing I do is art when I'm actually active on the channel, teaching how to draw. But I also do weird things, weird quirky stuff. I like physics and weird stuff, so I have videos on that kind of things, like different stuff like that. And I also do writing sometimes. I haven't done it in a long time. I actually more recently I should say in life, sold one of my novels. It's called, matter of fact, here's one of the copies I have right here. It's under my pseudonym, which is also my fiance's pseudonym. Basically, Samantha Stone, Many Nature, a New Kind of Vampire Novel. Pretty awesome book. Still to this day, it's still my son's favorite book. He's now 20 years old now? Yeah. So I think about that for a second. But anyway, so yeah, and it's still his favorite book to this day. It's a really cool book. So check out Amazon. If you have Amazon Prime, you can actually read the Kindle version for free. I also have a professional audiobook that was made and everything. Really cool. So yeah, it's it got bought out by a company that that's a long story, but yeah, it was cool. And I've also sold short stories and stuff like that. So I like writing. And right now I entered into the Big Break contest, which is that was called Big Break by, I think so, the screenwriting contest. I entered one of my screenplays into that contest, and I should know here in September. I forgot exactly what day in September they're going to announce the semifinalist. So hopefully I get the email saying I got the semifinalist. No, it's not a big deal. I know how the system works. Been doing it for a long time, so I just resubmit it again, different competitions, and like somebody's having a bad day, they start reading and whatever, they throw it to the side. That's what happens. It goes that way. But anyway, so that's a whole different topic though. So for those that want to know more like this, more physics and stuff like that, more about my philosophy, let me know. Definitely check out that Quantum Mirage. It's really, really cool. But yeah, so I was just trying to think anything else I want to say. Oh yeah, definitely share this. If you appreciate it, share it on your social networks, because it means there's a lot of people that might also really enjoy it. It's a really interesting, I think, a really interesting model of the universe, and one that naturally gives a possibility for life after death, and that's kind of cool. Doesn't mean there is life after death. I personally believe it for my own personal reasons and experiences and reincarnation and stuff. And if you guys want to know about the rest of my philosophy, like how reincarnation works and what ghosts are exactly, and how the ghosts work, what's the purpose of the ghost, what ghosts can do and can't do, and all that kind of stuff, let me know, and I can share that kind of stuff. All right, thanks for watching.